Hello.
Yeah, it is audible, ma'am.
Hello, Harish sir. Please unmute your mic, sir, and respond for.
Hello, madam.
Am I audible, sir?
Yes, madam.
Shall we start, sir?
Yes, madam.
Okay.
Madam, your voice is not audible, madam.
Hello, Ipudu?
Yes,
Hello?
madam. Yes, madam.
Okay, okay. Good evening, all of you. This is Dr. N. Pushpalata, Professor and HOD of EC Department, Annamacharya Institute of Technology and Sciences, Tirupati, co-coordinator of Atal FTP on integrating embedded system for Industry 5.0 excellence. First of all, I would like to thank AICTE for sanctioning the Atal FTP. My sincere thanks to our principal sir, Dr. C. Nathaman Reddy, and management who supported us in all the directions for successfully organizing this program. Now I would like to congratulate Dr. P. Harish sir, coordinator of this particular program. My heartful thanks to all the resource persons for accepting our invitation to deliver their presentations to this FTP. Last but not least, I would like to welcome all the participants for this FTP. Now I welcome Dr. P. Harish, coordinator of this particular session. Take the charge. Over to you, sir.
Thank you, madam. Good evening, everyone. It gives me immense pleasure to welcome you all to this Atal Faculty Development Program on integrating embedded systems and artificial intelligence for Industry 5.0 excellence. I am Dr. P. Harish, coordinator for this FDP and an associate professor in the Department of ECE at Annamacharya Institute of Technology and Sciences, Tirupati. This FDP has garnered an overwhelming response with the 197 registrations from all over India. As we move toward Industry 5.0, the emphasis is on blending advanced technologies with human-centric values such as sustainability, flexibility, and ethical innovation. Embedded systems and artificial intelligence are central to this transformation, enabling the development of smart adaptive solutions across various sectors. The objective of this FDP are to provide educators with a strong understanding of Industry 5.0 principles, equip faculty with the skills to integrate embedded systems and AI into their teaching, foster interdisciplinary collaboration across different fields, allow participants to apply embedded systems and AI concepts integration in practical scenarios, explore strategies for sustainable and flexible technological solutions. This program aims to empower educators to inspire the next generation of innovators and prepare them to excel in this rapidly evolving landscape. Now, it is my privilege to introduce the head of our institution, Dr. C. Nadhamohan Reddy Garu, whose visionary leadership has been instrumental in steering our institution toward excellence. Dr. C. Nadhamohan Reddy Garu focuses on innovation, research, and academic growth, has left an indelible mark on our institution. I request Dr. C. Nadhamohan Reddy Garu to deliver the keynote address for this FDP. Thank you, sir. Thank you to everyone.
Good evening, Dr. Harish.
Good evening, sir.
The coordinator of this particular Atal FDP, and the co-coordinator, Dr. N. Pushpalata, head of the Department of ECE, and many people, many resource persons like Dr. Ramakrishna Sai, Professor, Indian Institute of Technology, Tirupati, Dr. K.P. Naveen, Associate Professor, IIT Tirupati, Dr. D. Lakshmi, Senior Associate Professor, VIT Bhopal, Mr. N. Ayyappa, Senior Principal Engineer, Marvel Technology, Pleasanton, California, USA, Mr. Keshavan K. Mannar, Software Engineer, LinkedIn, Pleasanton, California, USA, Mr. M. Hemant, Lead Engineer, Fluence Energy, Bangalore, Mr. T. Mohan, AI Development Engineer, Vignan Technologies, Tirupati, Mr. S. Hemant Kumar, Embedded Engineer, Data Point Solutions, Hyderabad. So these persons of eminence, experts, expressed their consent for giving the guest sessions in this part of faculty development program this week. So my heartfelt thanks to all the resource persons for expressing their consent to be the resource persons of this particular program. Coming to this program, it's my honor to welcome you all to this faculty development program, the participants and all, on this particular integrated embedded systems and AI for Industry Excellence 5.0 is the title that has been proposed. This program brings together the best of academia, the best academia and industry, offering a platform to explore two of the most transformative technologies of our time, embedded systems and artificial intelligence. So I'd like to give some insight into this Industry 5.0, Industry 4.0, 3.0 and all. No, there is different phases of industrial revolution, in fact. So this Industry 5.0 is the future technology. So it's intended to integrate the embedded systems and AI as a part of the next phase of the industrial revolution. Hence, it is called 5.0, next phase of industrial revolution, fifth phase of industrial revolution. Industry 4.0, I think, was mainly focused on these things. Fourth industrial revolution, focusing on the automation and the data exchange in manufacturing technologies, particularly the automation systems, data-driven decision-making problems like artificial intelligence, machine learning, and predictive analytics. So these are the domains we considered in this phase. Is almost about to be ended, this particular thing, and the next phase 5.0 is yet to start. Is now starting. Coming to industry 3.0, that happened in late 20th century. So mainly focused on computer systems and the information technology, the applications of these things to the manufacturing and service related problems. And coming to industry 2.0, it happened in the 19th century, end of 19th century, the beginning of 20th century. Mainly the telephonic systems, telegraphic systems, assembly lines for the mass production, and the electricity, electric motors, generators. So all these things were focused in the industry 2.0. So in the industry 1.0, you know, at the beginning of the industrial revolution, so where the people shifted from the conventional, the hand tools to the what do you call the mechanical systems, you know. So these are the developments, particularly in the industrial environments. Talking about this fifth phase, these are the subjects being chosen for the 5.0 industrial revolution. The embedded systems, you know, are specialized computing systems that are designed to perform dedicated functions, often within larger devices. They form the backbone of modern technology, from household applications and automotive systems to medical devices and industrial automation. So these embedded systems are deeply integrated into our daily lives, yet their potential is far away from the fully realized ones. On the other hand, artificial intelligence, that is AI, represents the high point of human initiative, enabling machines to learn, reason, and make decisions. So replacing the human thinking and the human capabilities with the help of the machines. So by analyzing vast amounts of data and adapting to changing conditions, AI has opened doors to innovations that were once thought impossible. From predictive maintenance in factories to personalized healthcare, AI applications span across the industries, improved efficiency, accuracy, and with improved quality decision making. The integration of the embedded systems and AI is definitely a game changer. This synergy allows for the development of intelligent systems that can process real-time data, adapt to their environment, and perform complex tasks autonomously. Applications of this integration are all around us. Smart homes equipped with IoT devices, autonomous vehicles navigating safely, wearable health monitors providing real-time diagnostics, and advanced robotics revolutionizing manufacturing process. So all the various applications we are finding out with the integration of these two domains. These innovations are driving us toward the Industry 5.0, the next industrial revolution, which emphasizes human-centric innovation. Unlike its predecessor, Industry 4.0, which focused primarily on automation and connectivity, Industry 5.0 seeks to harmonize the collaboration between the humans and machines, that is, man-machine systems. By leveraging embedded systems and AI, Industry 5.0 aims to enhance not just productivity, but also sustainability, personalization, and quality of life. The scope for research in these areas is immense. As the demand for smarter, more efficient, and sustainable systems grows, so does the need for groundbreaking ideas and solutions. Research opportunities include the development of energy-efficient embedded systems, ethical AI algorithms, and advanced hardware-software co-designs, as well as exploring interdisciplinary applications in healthcare, agriculture, transportation, and beyond. As educators we have a unique responsibility to equip the next generation with the knowledge and skills to thrive in this evolving landscape. Programs like this are crucial for keeping us at the forefront of technological advancements. By understanding the intricacies of embedded systems and AI, we can ensure that our students not only learn the theory but also understand how to apply these concepts to solve real world challenges. I encourage all participants to actively engage in this program, absorbing the insights from our esteemed speakers and collaborate with one another. Let us use this opportunity to explore innovative ideas and spark a passion for research and development that drives both academic and industrial progress. I extend my gratitude and thanks to the organizers, speakers, and participants for making this program possible. Together, let us embark on this journey of learning and discovery, aiming to contribute to industry excellence and societal advancement. Thank you, and I wish you all an enriching and inspiring experience. Thank you, Dr. P. Harish. You can, transfer the mic to serve the speaker, the resource person.
Thank you, sir.
Harish sir, unmute your mic, sir. Unmute your mic.
Okay.
Thank you, sir, for inspiring keynote address, sir. Your insights have set the tone for the faculty development program, highlighting the significance of integrating embedded systems and AI in the context of Industry 5.0 excellence. Thank you, sir. Now it's my pleasure to introduce our speaker.
Problem from your end. Audio problem from your end.
No, Dilip sir, now is it audible, sir?
Audible, sir. Clear.
Now it's okay.
Okay, sir. Proceed.
Yes, sir. Now it's my pleasure to introduce our speaker for session 1, Mr. Hemant Mauluri. Is a lead grid modeling engineer at Fluence Bless India Private Limited, Bangalore, India. He has extensive experience of 14 plus years in the field of development of power system software, power system modeling, simulation, and consulting. His specialization and areas of interest include power system analysis, renewables, power system stability, smart grids, and microgrids. He had conducted several training programs for utilities, industries, as well as academic institutions. As a session, one will be starting by 6:30 p.m. We can have a 10 minutes break, sir.
Participants can stay in the line. Thank you.
I now request Mr. Hemant Mauluri to kindly take over the session and share his insights on Introduction to Industry 5.0 and Human-Centric Approach. Mr. Hemant Mauluri.
Hi. Hi, Harish.
Yes, sir.
Am I
Please
audible?
take over the session, sir. Yes, sir. Yes, sir. It's your voice is audible.
Just give me a second. Let me switch on my video so that it will be clear. Okay. Harish. Okay. Hello everyone. Am I audible? Loud and clear?
Yes, sir. Yes, sir. Your voice is clear.
Oh, fine, great. Thank you, Mr. Harish. Firstly, I would like to thanks to the organizers who gave me this opportunity to present an interesting upcoming topic, which is Industry 5.0 and its human-centric approach. So let me share my screen. Okay.
Screen is sharing, sir.
Yeah. Hope all of you are able to see the slideshow now.
Yes, sir. It is sharing.
Yes, sir. Yes, sir. It's sharing, sir.
Okay, great. Thank you for confirmation. Okay, this is nice. Fine, guys. Because I'm little late for the introductory section, may I know how many participants are there and what is their background? If everyone is allowed, or it's the organizer can just brief me of who are the participants and how many are the number?
Sir, PG students and research scholars and from persons from industry and academicians are allowed for this program, sir. And
Okay.
the count is around 150, sir. Now it's around
Great.
157. It's going on.
Okay, really awesome number. I think so. It's a lot of background work from the organizers to pull so many people for a online lectures, guest lectures nowadays. To get people for the FDP is also difficult, right?
Yeah, of course.
Because with the pandemic, there are a lot of online sessions that are going on, and getting people for those online sessions are also difficult. Okay, nice, guys. This is going to be a small. Yeah, madam. You are saying something, madam? Okay. Fine, guys. So.
Sir, I request Dilip sir to unmute all the participants, sir. Sir, mute the participants, please. Dilip sir. Sir, Hemant sir, just a minute, sir. I'm asking my technical person to
It
mute
is
all
done,
the
sir. It is done. It is done.
Yeah. Thank you, sir.
Thank you. Thank you, sir. This is going to be an interesting topic, which is like kind of advancement, right? Everyone will be having curiosity on how the future is going to be. So I will try to make it interesting. I don't have much of slides. I don't have paragraphs. Just I have some bullet points with minor things. So let me see how best I can make interesting this topic. The first one, as the topic headline says, Introduction to Industry 5.0 and its human-centric approach. Before going into the topic, let me understand Introduction to Industry 5.0. So, and it's human-centric. So there are multiple revolutions that happened. Why only this has a tagline called human-centric approach? That's one of the interesting things that we are going to look at. What is happening? What is the past revolutions that we have seen, and why we are naming it as human-centric approach? Why this tagline is making it more important for us going forward with the future. Hemant. You can call me Hemant, and then I'm working presently as a lead grid modeling engineer at Fluence Energy. It's also one of the advanced topics that I'm looking at, which is mostly onto the battery energy storage systems with the grid forming inverters, which is the present buzzing word of the power system industry. So let me move the slides. Okay. This is the brief contents that I'm going to look at. The recap, as I said, what is the difference between the earlier revolutions, how they were evolved, and it's a small brief, 5 minutes or so. It's what is for each industrial revolution. I will give you an example and take it forward. Then the present, what is the Industrial Revolution 4.0? What are the concepts that were newly introduced because of that? What are the main drivers of it? And what are the achievements that we have got out of the Industrial Revolution 4.0? But this is what is Industry 5.0 and what is its human-centric approach is going to be the main topic here, with its impact that it is going to be created in the future. What are the main drivers of it? To give some day-to-day examples, or what is going to be the futuristic examples that I'm looking at. And what are the benefits of it? And at the same time, what are the challenges it comes? Because every coin has two sides, right? Always it comes with a benefit, also with a challenge. So how to overcome, what are the challenges, what are the benefits, and what is the future direction? Because as any researcher who attends this faculty development program, FDP, or any lecturer, professor, everyone has a research mind in that. So what is the future direction that we need to look at? So then I will open the forum for an open Q&A and whatever, it's like discussion that we can have a healthy discussion based on the time. Then to come with the recap, this is the revolution that we are seeing. The first revolution was started when a steam engine was introduced and where the mass production by machines was started. It was way back in 17th or 18th century, the first steam engine was founded, and then there it starts. So that the travel, the commute is the basic problem, where we used to go with a bullock cart or whatever the carts that were available. But then once with the invention of a steam engine, there can be mass movement of goods that were able to happen. Mass movement of population can move around. So then we got, that is the first industrial revolution. And the second industrial revolution, once we have a production, when we say mass production, but then there comes, we formed the assembly lines. We, in the sense, I'm not saying that of any country, it's on the whole world as a human being, where we formed the assembly lines, which are still existent. Even till today, all the manufacturing industry, if you go, we have assembly lines. Where we formed equipment by part, it has a sequence so that it goes through the assembly line. By the end, we get a final product. That's where we started the assembly lines, and then the production pace has been picked up. But the third one is the automation of the automated revolution, which means for all these assembly lines, whatever I was speaking, we try to automate the process as much as possible so that we get the efficiency in the production line. So we can get better production outputs, we can get better things. And we had introduced the IT systems, kind of, we will be having the computer comes along with the assembly line, most likely. It's like the computer is getting added to the assembly line. We know what are the parts, how, what. So it's like more or less automated with IT infrastructure into it. But the present industrial revolution that we are looking at, the present we are living, is the digitization, which means that there is a lot of data that is revolving around. There is a lot of data that is getting generated. The data is still as part of, it is not fully converted into information. The data generation is a part, but getting it as a meaningful information is the next change. That brings a lot of value addition into the analysis, where the analysis can drive it to the decision making. So at present, we are in the era of handling data. We are trying to get as much of data as possible, and we are trying to use the data to the extent possible. So what are the in-depth of this? I will be able to say you in the coming slides when we get the recap of the present Industry 4.0, which acts as a base for the Industry 5.0 revolution. Where here, what is happening is like we are trying to utilize the resources to the extent maximum possible, which makes beneficial for the people. We are slightly neglecting in all these revolutions. We try to improve the efficiency. We try to improve the production. We try to, for the sake of us, improving of us, we tried here. But then with the era of past 2 decades or 1.5 decades or 2 decades, where human is becoming sensitive with the atmosphere, with the global warming hitting, we wanted to come to net zero, carbon deneutralization. So we are going towards those things. So then we need a sustainable environment so that the planet can be passed on to the next generations. Until now, I don't want to say in a negative way, but rather on a positive side, we have depleted the natural resources to the extent possible. So now the human beings has come back saying that no, we need to make the planet survive, sustainable for the next generations to live. So the sustainability is going to be the key concept of Industry 5.0. Also, here, if you see all the automations and digitalization, most of the concentration has gone into automation of the things, where at a point of time when I'm as part of an industry, where as my experience, I was a R&D engineer, I was a consultant, I was a designer, I am into the technology team, I am into the manufacturing team. I had different hats on me, where I worked as a researcher, I worked as many hats in this past close to 15 years, where we saw that in the recent past stint, where I was a technology team, as part of technology team, where we had jokes in our team itself. We were trying to automate the things to an extent possible. My job is going to be relevant for me, for the company in the next 2 years. To that level, it's like, as a part of power system engineer or development of a model, we were actually seeing what is the physical equipment, what are the controls, what are the communications that were there, and we try to develop a model which is as close as possible to the physical equipment. Those are called digital twins. I will come into those things in the upcoming. But then, now we try to automate in this 4.0 to such an extent, when there is an upgrade in the physical equipment, once they say this is a firmware that got upgraded, automatically it creates a new model with a benchmarking reports out. So at the end of the day, I myself making irrelevant for the society or for a job. So in this regard, but now what is happening here? It's not all about that. We wanted the human being as a core, that's a centric. Human as a center, but all these automations, robots, whatever we call, whatever the technology advancements that we are looking, is going to live together. We are not, it's like collaboration. It's no more the robot or the system that we are developing, automation that we are doing, or the digitalization that we are doing is not a slave. We are going to work as collaborators. They are going to be our colleagues. We call cobots. No more robots, it's cobots, collaborative robots. That's a new term that's getting buzz now. Okay, and making environment sustainable. So whatever the minimal resources that we can use, we should be able to minimize the utilization of resource, but at the same time, we need to maximize the production, we need to look at the customization, and we need to see with the other terminologies. Here, what happens is like there was a famous WhatsApp forward, or if you see the Insta Reels or a LinkedIn post, there was one post I came across some good amount of days, almost the past 1 to 2 years. There was one influencer who was speaking, who says that my grandfather used to work for the sake of feeding the family, for the sake of living, where the bosses were like bossism, where they beat, physical abuse, everything was there. But they were looking for a food. But then my father's generation was like, they had a comfortable house, they tried to get it, but they were looking for the next generation, for the sake of comfort. They wanted to get a house, they wanted to get a car, they wanted to. So that was, but my generation was kind of luxury, saying that no, I don't want a small house, I wanted a 4 BHK, I wanted not a small Tiago car, I wanted a Innova or High Cross, whatever. To the next level, the luxury is what we are looking at. But my next generation is not that way, right? It's like we are used to go for a TV, press the button, the channel number, tune it, hold an antenna. But now the voice assistants, my kid says he's reluctant to type also on a keyboard. He says, hey Alexa, get me this out. So the generation is moving, but you should not take the human out of context. So that's where this Industry 5.0 is going to bridge that gap. Still, human is making the relevant, he is the center, but the labor job is going to move around. That we will see in the upcoming slides. So what is Industry 4.0? What is the present status? What are the new concepts it introduced? And how things are changing over time. Let's see. The first one, we have moved out from the physical systems. As I said, assembly line, which was manual. Okay, we will be having a sheet which says step 1, you do this. Step 2, you do this. Step 3, this will be done. This step. So there will be in charges for every steps, and they need to do it step by step, and it gets manufactured, any product. Or for that, anything. It's not like, say, if I wanted to develop a software, these are the first literature, this has to be carried out, and this has to be the next meeting, and this has to be the next level, then it has to be going to development, POC, then it has to go to production grade, then it has to go for testing, then it has to go for release. It's like there are, but then these all steps are now getting bulldozed, or I can say they are overcoming in a simpler ways. They are bypassing. Now, if I wanted to develop a small piece of code, earlier we need to sit and code, but now I can ask ChatGPT or Copilot saying that, hey, ChatGPT, can I get this part of code? I will get the ready-made code which is available and I will just use it. But then it is not that. We moved out from a physical system to a cyber physical system. So where there is a connectivity comes in. It's like, now we can see most of ACs, if you say air condition, we have an IoT on that, which says you can control your AC from somewhere else. If your car has a remote, the recent high-end cars, you can switch on your AC before 15-20 minutes. By the time you enter into the car is already cold. Or 20 minutes earlier, you can switch on. So by the time you enter into the house, the AC is on. Hello, madam. Okay, so that's the digitalization has come into the physical systems. It's no more a physical system. You need not to go and press a button to activate something. You can do it from your phone. You can control, if we have seen some of the latest video from our famous actor Chiranjeevi Garu. If you see that, he said that he has the control of all his house, electric lights, everything on his mobile. He can see it and he can control. So it's like the digitization has entered into our day life. So that becomes cyber physical systems. And when you see at a manufacturing industry or any industry for that matter, we need this digitization has brought in integration between suppliers, production lines, and customers. So multi phase integration is happening. So it's like the more with the data. It's all Internet of Things, which means that right from our day-to-day life to our power or mechanical systems or civil systems to whatever, it's no more a core engineering. It's like earlier we used to say, yesterday I was in one of the AGM of our IEEE thing where we were thinking AI or the machine learning or all these things was embedded into a core engineering. No more, it's like civil engineering is a core engineering, electrical engineering is core engineering, mechanical, they were core engineering. But all this digitalization has entered. Now, no engineer with only a single skill set says that, no, I can solve the boundary conditions in a mathematics, M2, right? It's one of the famous subject where most of the people struggle to move upon. I know many of my friends who struggled passing M1, M2. But then, even the highest talented who pass M2 with 98 marks out of 100, but still that skill set is not going to be sufficient. By the end of the lecture, I will be able to say with an example how things are changing. Why only a single skill set is not going to be sufficient for us to survive. So it's like these all things has already embedded into the core or whatever we say. They were already part of us. The next, using and development of digital twins. This is an interesting topic with the advancements that we get in our laptops or computers or whatever you say with the digital infrastructure that we have. Now, let's say earlier when we have developed an insulator or when we have developed a HVDC systems or when we have developed something, there was physical testing that was getting involved, but it was cumbersome. Now, let's say our ISRO was sending a lot of satellites and things. And recently our SpaceX, where they're docking the 2 satellites, right? Had a lot of simulations that ran. Even they analyzed a lot of data, even in the physical equipment after they sent the things to the orbit. Then once they brought it closer, close to 3 meters, and they have moved it back to the safe, downloaded all the data, they have done all the simulations, they analyzed the data, and then they had taken to the next step. So that is what is called digital twin, which means that we are developing a digital twin. It's like most of us, I think so, we are all Telugu, if then I can say Kavalalu, we say that, right? Twins, Kaval Pillalu, which identical, both are identical people. So then we are trying to replicate the physical system into a software system as close as possible. That is called digital twin. So those digital twins, which means that when I get a data from one, I try to simulate here, which means that it reacts, the actual physical equipment also reacts in the same way, responds in the same way. So that is called digital. With the advancement of the computational power, we are able to do all these things. So instead of doing a physical test on the equipment, we are doing it on a laptop or a computer or a supercomputer or cloud computing, whatever we call. Those are all the concepts that are getting introduced. That is called digital twin. Then we get big data. So I said, we are having sensors, we are having a lot of data collecting devices now. We are collecting data from every part, everything. It creates a lot of data every microsecond, every millisecond, depends upon. So now we are seeing at a meter which collects the sample in the range of microsecond. for our analysis, we are having a meter, we go and connect a meter. So we get the data collecting at the level of microseconds. So which gives, if I collect the data for 1 second, it's like 10⁶ samples per second. So you will be having a lot of data. Then you need to, that is called big data, which means that there is a lot of data available. So then we need to process it to generate a meaningful information that is used to take the decision. So that is one of the new concepts that is introduced in the Revolution 4.0. Then to store this data, we are collecting a lot of data, but then earlier, my young age, where I started using a computer, maybe around 7th class, 8th class, somewhere, I think so, 7th, no, 5th class, where there was a computer in the village, we need to go and play the games. There it was like 128 GB, no, 64 GB, if I'm not wrong, is the hard disk size. And the CPU is this much size, and you'll get, but then now we have 10 TB hard disk, portable hard disk drives, right? To cloud storage, which goes to, we can say, practically unlimited, where all this Amazon, Azure, where all the cloud services, right? They stack it, actually, they vertically scale it and horizontally scale it. So you get practically unlimited storage, but just is all paisa mein parmatma hai. At the end of the day, it's all money that rules. But then all this big data that is collected is getting stored. For that, we introduced a concept called cloud storage. And finally, not last but not the least, this is the latest and greatest thing, where we say the data privacy is one of the most important, as well as cyber security, which means that all this, now say this cyber security, as I said, we are having some sensors or IoT devices placed even on most of the equipment. If you say a power system, as a power system engineer, I will give you an example. We have something called SCADA, which means that you get the data and you can control, supervisory control and data acquisition. Basically, most of the days, until a decade back, we say we were using a part of SCADA, only the data acquisition was happening. But now, but we are getting the control as well at present. We are doing the control. And recent, with the Russia and Ukraine war, none of them is officially, they say that the one guy will say, but the other will never accept, but that's all geopolitics. But then if you have observed some of the news articles, there are blackouts that were happening in Ukraine. So which means the Russia will take over the control of the other power system. They will switch off a line, they will switch off a transformer, they will control. So once a line or a transformer goes out, then what's the impact? If there are some electrical engineers, they will be able to understand. So that's what, which means that it becomes dark. All the power can be switched off. I can control your system. So cyber security becomes a lot of things. And recently we will see, right? There is that malicious links that you get, you click, your laptop will get freeze. It goes into the control of the other thing, and they will ask you some money. If you deposit, they will release your mission. So a lot of things are happening. So then that comes with cyber security. So when you have, if I see here, we moved our physical system to cyber physical systems, we introduced, and then we integrated the Internet of Things, which means that we are trying to collect as much of data as possible. And then we are developing a digital twin to facilitate us. And because of all this, we are getting a lot of data. And then for this data, we are creating a storage. And now we are protecting the data and we are protecting our secrecy. So it's all, we has gone into a cycle of change. So these are all the new concepts that are introduced in Industry Revolution 4.0. So, but with this introduction, so what is happening? What is driving this 4.0? What are the main drivers that it's happening? As I said, the internet and IoT. If we see, we remember close to a decade back, 1 GB of data is like 250 rupees or 300 rupees, depends upon the operator. Airtel, Docomo, right? Well, so, but now we are getting 1 GB of data in less than 10 rupees at a higher speeds. We were speaking about 4G, 3G first, but then it comes to 4th generation. 5th generation is now 5G, which is close to 1 Gbps. And now 5.5 generation network with the Geo network, it's rolling out, right? So which is giving until 10 Gbps, which is a kind of awesome thing. So you get a lot of connectivity, lot of data, which is the major drive. See, without internet and this kind of speed, we may never think about getting so much of data from each and every equipment that we have on the physical system. But now, because of the internet, the IoT came into picture, and this is a major driving force for the Industry Revolution 4.0. The next, earlier, the business unit is different and the manufacturing was different. The business goes and they will try to get something, but the manufacturing team says that no, we have thought it this way and this has been integrated into our assembly lines. This is how the equipment is getting manufactured. These are the limitations. But now it has changed. The business and manufacturing things are getting integrated. So when we go for a new product design or new thing, as I said in the previous slides, the customer, business guys, and they're all integrating. The multi-facet integration is happening. So that is the human mentality is changing from what is available. I was supposed to choose what is the best that fits my requirement, to the customer saying, I need this. Could you customize and give it to me? The perception is getting changed. The way the human tendency is looking at is getting changed. So the units are getting integrated. So we get better efficiency, better production, better customization. Things are getting changed. And as I said, digital twins of the real world applications. This is possible with the latest computation power that we are acquiring over the years. We were thinking of high performance machines, HPCs, then we moved to supercomputers, now we have moved to quantum computers. It's moving fast, where like the speed of computation, the hardware availability, we say everything is interlinked. When we say we got a better hardware, we are going to better software. Once we have a better software and computation, then we're cycling back to better hardware again. So it's like it's getting interlinked. So these are the major drivers which is driving to efficient production lines and smart products. If I say on the efficient production lines, as part of my past 6-7 years of journey, or no, past 10 years of journey, where I was into the hardware product development as well, embedded systems, all those multi-directional, where I went, I was part of developing a hardware transmission line simulator, which is supplied to all the education institutions. I was part of developing a HVDC simulator. Or I was also part of an actual onshore and offshore wind turbines development as part of Siemens Gamesa. I was also part of a product as a technologist back and who worked for developing a inverters thing. So there, if you see the production lines, they are getting much more efficient with all the data that is getting available. Okay, the IoT things, the internet, with the internet availability, we were getting a lot of data, which as a technology, we sit on the laptop, we analyze most of data, we say that no, in this production line, this part can be improved. So instead of taking to build a turbine, let's say 1 week to build a nacelle, with all the data that is getting available with the internet and IoT and with all the business inputs, we say that, fine, if you install a turbine in 3 hours, we get this much of money. If we go with this, it changes. So everything, the data is available, the analysis is available, As a clear example with business and manufacturing integration, what happens is like, if I see a wind turbine, most of you might have observed, mostly in the Anantapur district, where we have a lot of turbines, or if you have gone to Tirumala, when you climb the hill, you will be able to see a lot of turbines. Each turbine installation used to take maybe a couple of days. The the fan wings that they were huge in size, and it requires huge cranes and things. Now, if I say the length of that wing of a turbine that we see on the land is each is around 40 to 50 meters, the same kind of turbines in the sea also they will be having wind turbines, where each blade, that wing, is like 120 meters. So the end to end is 250, 260 meters, the diameter of the wind turbine. So which is like kind of, if saying 4 football stadiums, one after the other, if you keep, that is equal to 1. Now, to install that, it's a huge effort. You'll be having large cranes, which were specially designed. They were kind of the biggest cranes on the earth. Ideally, they actually take the specification. The crane manufacturer comes to the OEM of wind turbine. They say what is the weight that I need to lift, what is the size, and what is the height. Because the height is also 280 meters, 320 meters. So 320 meters. And the wingspan is like 250 meter, 260 meter, the diameter, and half of that is the radius. When they wanted to lift, there will be a lot of wind, and you need to go and correctly plug it. Millimeters accuracy is very much required, and it's very cumbersome, where we used to take 3 to 4 days per turbine for the crew on the vessel, the ship, the vessel we call. They take 3 days, 4 days, sleepless nights, because when the wind is low, when it is oscillations are reduced. But then we come up with the approach called electronic horizontal blade mounting system, which will be done electronically, where how much gain I need to push, how much energy I need to give so that it goes and clicks, where the total installation, that all 3 wings get installed in less than 2 hours or something. The cost of the vessel per hour is like in millions of dollars. So there is a lot of money that gets saved. 3 days to 2 hours. Now you can compare, right? It's like from almost 72 hours to 2 hours, and you save lot of money. So everything comes. That is possible because we have a lot of computational power. We got all the data, all the movement, what is the wind speed, how the oscillations are happening. We kept a lot of sensors on the blade. We collected a lot of data, what is happening. Then we integrated that with the business and manufacturing. Says, okay, if you can save it here, we can save so much. So the product price comes down, so the profit gets increased. That can be achieved with these digital twins, and then we got efficient product lines and smart products. So these are the major drivers of the Industry 4.0. Here, the major concentration is like increasing the efficiency, increasing the profits, increasing the timelines. This is what we are motivated at. We don't care about what is the environmental impact, what is happening. That is all secondary, people speak, but then it is not going into the production lines. It is not happening. And what is the achievements of this Industry 4.0? The main achievements is like decrease in production costs. The earlier a TV, what was the cost of a 55-inch LED TV? And past 3 years, if you see, there is a drastic reduce in the prices. They're coming down. Because the efficiency of the production lines are getting increased, the data analytics are played. We are having logistic costs reduced. As I said, right now, a vessel used to take 3 days, now become 2 hours part. So there is a lot of, I say for that, it's very enormous change, but then not everywhere it's the same. So we say around 10 to 30%, there is a change in the logistic cost, the production costs are coming down. And the quality management. With most of digitization, most of automation, the human errors are coming down because human involvement is coming down. So you are not allowed to take any decision. More or less, it's like everything is managed by computer and you are becoming a slave. Rather than computer helping you, you are helping the computer. And it's going in a reverse direction. That quality management costs. Earlier, we used to say there are a lot of testing engineers in the software domain. But then, now, the testing is getting automated. There was automation testing. If you heard until 5 years, 6 years back, there was automated testing, or even 3 years back. But now, there is a lot of threat to the testing engineers. People are saying, oh, what happens to my job with the AI? What happens to with this machine learning? Because the testing job itself is becoming irrelevant because most of the cases during the production stage itself, they are doing. Recently, we have read an article, the outage time on the Netflix. With most of you might, with the OTT culture, the Netflix outage time is really coming down. The disruptions in the Netflix is really almost negligible because they have created a small testing thing called Chaos Monkey, a small software tool they have developed. During the production time itself, they create a lot of downtimes. They create all kind of worst scenarios. So they can test it during the production time itself. So when it comes to actual life, we need not to test so many scenarios. They are already tested. They have been already taken care of. It's all done. So the quality management costs are coming down. These are the major achievements that we are bringing in due to automation, due to increase in our computing, and improving in the process efficiency. If we observe here, it is all happening in a reverse direction. Rather than human taking the forward step, the machine is taking a forward step. And we are not bothered about sustainability. We were not bothered about any other. We were just bothered about the profitability. We were looking about efficiency. We wanted more production, more money, more things. But then the days are getting changed where everyone is getting used to no. If this kind of depletion happens, the survival on the earth is getting difficult. The human may be taken over by the machine. As you see in this Robo movie, right? One robot creates hundreds of robots and then it takes over the control on the city. So it is going in a wrong direction, basically. So now, as a human being, we are coming to Industrial Revolution 5.0, where humans should not become irrelevant. Rather, we should be the center, and then we need to make sustainable, environment friendly, and we need to let's live and co-live. That's the. So what's the main topic? It's like we are humans and machines are going to work together. We don't want the machine as a labor to us, but rather we wanted to work together collaboratively so that we can survive and better foster the future. This where we say that there are lot of definitions. This is one I took for showcasing here, where it says Industrial Revolution 5.0 refers to people working with robots and smart machines. It's about collaborative robots, the new term, cobots, helping humans work faster by leveraging advanced technologies such as big data analytics. So until 4.0, as I said, we are getting big data, we are getting a lot of data, but then that is passed on to a different team to analyze offline, to create a decision, and then that is getting back to the implementation in the production line or whatever. So it's like there is a process. But then with this cobots coming in, we used to say, right, one robot is equal to 100 people's brain, where it computational skills, based on the computational skills and abilities. So we are looking at real-time data analysis. Going forward, we are going to look at real-time data analytics and analysis to get a informed decision, fast decision making to improve our efficiency. Also, it's fostered in a way when you have real-time data, you can actually optimize the utilization of resource. You can actually optimize. If I say, if I can reduce 10% of steps in the production line, I can save so much of energy. I can become more carbon neutral. I can become fast. So it's like every step optimization brings in more, but I should be sustainable consciousness. So we are going to work collaboratively with robots by using the advanced technologies, and we improvise the process. So what happens here? These cobots will take care of safety and risk. So if there is heavy lifting, until now humans need to tie something to the cranes and they need to lift, and there can be hazardous. We as a product manufacturing industry, we used to hear that there is loss of life. When I wanted to install a wind turbine, there is a loss of life. Suddenly the nacelle has fallen, or there is a big equipment that has fallen, and then there is loss of life. All these, or even in the factory, if we say, during the assembly or something, there is loss of life. When you work with the power, when you work with mechanical systems, or when you wanted to do some construction, or when you wanted to do some labor work, there is loss of life. That there are chances. But then with these cobots, we can use them where there is a safety concern, because they are much more precision targeted, where even if something wrong happens, that's a mission. We can build it back. It's a mission, right? But we can see, we can reduce the risk and improve the safety. This is what we are looking at on the Industry 5.0. But as I said, this is on a paper or on a black and white, whatever we can say. But how it is going to impact our human lives, what are the positives, what are the negatives, and how it is challenges, what are available, what are the benefits, that let's go into the next slides. As I said, what is the impact that it is going to create? The first and foremost, I can say, with these cobots coming into picture, with a lot of decision conscious decisions that we are going to take, there was one perception that is very much aware, even at some point of time, even we are worried, saying that with all these kind of robots and automations or AI and all these things, most of the jobs may become irrelevant. There is lots of jobs in the system. But the catch, there is lot of jobs that becomes irrelevant, but which are dull, dirty, and repetitive tasks. See, when we say about even in these advanced days, till today, there is a human intervention. If you wanted a sewage line get disturbed, or we even still we see there is a human being entered into the pothole there, and they will clean and all. No, the quality of human being life has to be improved. It's not only educated has to enjoy, but the uneducated or the lower. It's not that. Everyone has equal life. So the technology has to actually better the human life. It's not only automation money, but it has to, the final objective of technology development, as someone said, it should improve the human life altogether. So we can use a robot for cleaning that. We can use a robot for doing a repetitive task. So these kind of jobs were actually going to come down, but not all the jobs. Be informed that we need not to be panicked onto that way, because already the human life, humans are getting aware. The human-centric, that's the name of 5.4 revolution, is human-centric. It's like development of human era. It's not like automation, something improve is not that. It's human is a center, quality of life has to be improved, the sustainability has to be improved, and then we need to co-live and let live. So that's where the jobs are going to come down, not at every place. And on a contrary note, there will be many jobs that gets created in the intelligent systems arena, AI, robotics programming, maintenance and training of those robots, scheduling, repurposing, and invention of a new breed of robots. It's not that at present we have, let's say, with a 6D arm, we may invent 10D, which gives us more flexibility, which helps us in our daily life, which improves our quality. But for that, it's not so easy, right? There are a lot of new jobs that gets created. That is a perception that we need to look at, rather than looking what happens to my job with this AI. No, people are getting aware. Now, even the companies are getting sensitized of that. We are here not to make ourselves irrelevant, right? At the end of the day, as a engineer, I need to survive because I have a family. If I become myself irrelevant after developing so much of automation, why I will do that? So we are all humans. We all have the jealous, and we all have that kind of swartham. We have that. So we are all humans who are going to take care of all this. We always want mission to help us rather than to rule us. So that's going to be taken care of. There is a lot of jobs that are also going to get created, but they are all highly skilled jobs. That I will say you in the coming slides, what are the challenges that are going to give, how this is going to change the arena of us. And what happens with this cobots coming in, with 5.0 revolution and everything, all these labor tedious jobs are getting reduced. Repetitive jobs are coming down, but the creativity of the human brain is coming down, is getting up. The upliftment is happening at the creativity level. So which gives more satisfaction for the people. Then what are the drivers for this? We require at present, the bigger the computing, whatever the hardware and software that we get, that is the bigger driving force of doing all this. And blockchain technology, which gives more security to us. It's not like a single person can do anything, which gives a community approval. It's more robust. It's like more secure networking. Just a second. Sorry for the interruption. Okay. Then we are looking at the collaborative robots or the cobots as one of the main. It's like they are going to help us in a bigger way, which is the main driving force to the Industry Revolution 5.0. And we say the big data or the real-time data that is going to help us. And the 6G and the future. As I said, in the 4G revolution or the fourth revolution, we have 4G or 5G networks. With the network speed and bandwidth availability only, we were able to do this, right? But with the 5.0 revolution, where with the 6G and future, we were hearing there are specific bandwidths that are getting allocated. If you see in the recent auctions for this bandwidth, someone from the communication departments, ECA and electronic there are specific bandwidths that are getting auctioned for the big industries. So what happens? That bandwidth is allowed only for that industry operation. They have branches at multiple locations. It has their own secure network. As I said, when we have a lot of data, we also prone for cyber security is also our major. So that bandwidth is allowed only for that industry. So then they have better, we say, safety on the data or the process. So no one can interrupt the process. They have their own thing. So that's going to be how the 6G and its coming generations are going to shape up the future. These are the major drivers for the Industry 5.0 revolution. Then some of the examples for us to look at. If I say a smart hospital, if we see, we say that laparoscopy surgeries nowadays are becoming, but it requires highly skilled doctor. Getting a highly skilled laparoscopy specialist is also a challenge, but that can be performed easily by a cobot. Or if you wanted to, as I said, the customization. So we can say the requirements can be very much customized with the advanced technology. If I say a person, now if I say we get these joints, right? For this orthopedic, some accident happened, they will replace the actual leg or hand or something with the implant, let's say. That will get in some standard sizes. So we need to choose the best, or we need to give some order with the size and all. But then we can get better personalized implants. Look at it, because with the advanced technology, you can take the other hand and they can synthesize the data and they can give you the other hand, which is very much close to resembling the thing. You can get into the personalized customization for a customer. The assembly line can be customized on the fly. You can say, okay, fine, this is the 3D image or 4D image. Now you develop according to that and give a physical product. Where we can see, you can get a mission tied onto you, which monitors your glucose insulin level, continuous 24/7, and it can give you a customized insulin injection cycle, which says that no, during this time, this is the insulin instead of a fixed cycle, it gives you better flexibility. Or during kind of pandemics, so there was a lot of what you call discussion that happened, right? Even still today, WhatsApp, the Meta, they were looking at the robots, or it's like AI dependent screening of your medical records, and you get a prescription out of that, or the next guidance out of that. So it's most of the preliminary analysis at a hospital happens using the AI or the computer or the new methodology, so that it reduces the burden onto the human, and it can point out directly what's the issue. It can help the human rather than the overcrowding onto the specializations or specialty hospitals. If we go, there is a lot of crowd in the specialty hospitals. Even when we go, I'm in Bangalore and I go to a Manipal hospital or a Aster hospital, there is a lot of crowd. There's a lot of crowd. So these all can be minimized. They all can be reduced. They help the humankind. Similar, we can say manufacturing industry, which says how to develop a process so that end to end, now they can create a process
Hello. Participants, please stay online.
I'm back. Hello.
Yes, sir. Audible, sir. Please proceed.
Yes, sir. Yes, sir. Please, sir.
Sorry, I don't know what happened. Maybe after an hour or something, it kicked me out. Let me share my screen back. Okay. Okay. So now, manufacturing industry. When I come here, it can actually we can create a process where until the product goes to recycling, it's not ending at. If I go to any apartment, I can get a tractor full of e-waste. Because the gadgets are increasing day by day, the technology is improving, so we wanted to change our laptop, we wanted to change our monitors, we wanted to change our Bluetooth, everything, mouse, everything is getting changed. We have 5 people in the house, 4 people in the house, everyone wants a mobile. After every 2 years, we need to change it. There is a lot of e-waste that get generated. There is a lot of wood waste. There is a lot of every waste that is getting. We can actually create a process until the recycle happens, which improves our system on the longer run. So we can reduce the environmental impact. So this is something that we can actually achieve with Industry 5.0. There are many examples, and I can say we can create a really impact with this lot of advanced networking or robots or with this as a disaster recovery management. Now it's becoming really tough and challenging during a disaster like floods in Uttarakhand. Until the flood comes slightly down, we can't go there because it's a high risk job. But with these robots or cobots that comes in with a lot of data available, a lot of advanced drones, technologies that comes out, we can actually improve the disaster recovery management. We can replan the complete thing so that we can reduce the human impact. On a positive side, right? We can think on the other side. Smart education. If I see, there is a paradigm shift. If I interact with some of my colleagues who are in the teaching field and who are into the educational thing, who are running coaching centers, all these, there is a lot of change with the NPTEL videos, where earlier only few IITs have that knowledge, but a really good professor creates a video which is available to anyone. Just they download, they get a lot of knowledge which can be transferred to the student. Or a student can go through that and come back to a professor saying that I have doubt in this particular thing. So that can. Or if not at that level, with the level of my kid who is going to class 2 now, when I see when we are studying at a younger age, I remember year. My science teacher has drawn the years and it's all internal parts in a classroom board, who took pain for drawing that very neatly for almost 2 to 3 hours he spent on the blackboard with color chart pieces, very neatly drawn. But we have 3 to 4 sections. What happens? Section 1 in my section, he has drawn it. For the next science, the section 2 was sitting in that classroom because he can't spend again the 3 hours in redrawing it in the next classroom. But now what happens? All these digital boards, they're getting really bright, colorful, clean explanation. They can change, they can do customization, they can zoom in, they're getting a lot of visible learning. There are a lot of visible learning, the smart education, we say. And there are, even I see, recently one of my colleagues where we say, what is a vaccine? We were just discussing something, and all of a sudden something called as what is a vaccine? A class 2 guy or class 3 guy, he said, what is vaccine? It's like saying that, okay, the same virus or bacteria in a mild dose, we trial it and then it enters into body. So the body develops antigens to that and we are ready for it. I was like, oh my God, until recently, we doesn't know what is vaccine, what is the technicality behind it. But the kids are very much knowing it because that's becoming smart. The blackboard is coming down, whereas the sense board, the word called sense board. They say all the 3D, they touch screen, they do everything, they get it in real, how close to the real, they're able to see that. How the heart works. We were drawn with black and white figures or whatever the professor or college, my teacher has drawn on the blackboard. I was able to see under thinking something, okay, this is how the heart looks. But now, the younger generation are not there. They were having a really clear picture on how the body is, what are the different parts, how the lungs look, how the heart looks, how each chamber works, how the flow of blood is going on. So the smart education is bringing a lot. So we can bring in much more advances. I was seeing the recent article with Sony PS5 and about the latest PS6 or PS7, whatever PlayStation. They're really introducing a concept called smelling. So when you're going on when you're doing that onto the, what is it called, forest, you really smell it. So it's something going to change. So this is all going to change. The evolvement is going to change. Or a supply chain management. During COVID, we saw how a disruption in supply chain management can create issues for the world. We can make it much better. If everything is robot operated or we can control with their collaborator, we need not, even we sit in the home, we need not to cross the borders, nothing. The transportation can be handled by robots. Things we can call them together, right? There is a supply chain management, resilience of that is much more better. As I said, smart hospital with cloud environment, the sharing of data, everything becomes much more. Improved production. So there is a lot of advancements that actually brings up the future can be completely different. Everything is sustainable. That's when we say all this, it's not of automation is done. Now we are going to a different level where humans are creative thoughts, where the brain is still with the human, but all the labor work which is having risk and repetition is getting outsourced, or it's like moved towards the robots or drones or whatever mission. It's all a smart mission. I can call it as a smart mission. Then what are the benefits? Now, after speaking all this, yes, sir, you have spoke so much. It's enough of time. But now when we see what are the tangible benefits, at the end of the day, what is benefit to me? Customization. If I see with the present 4.0 itself, there is a lot of customization that is happening. If you see these e-commerce websites like Amazon or Pepperfry or something, you can project that onto your room. You move the camera like this, and then it gives a 3D image on that. You see whether how it is fitting my room. So you are choosing that. But with these new advancements, these additional data, all this customization, these efficiencies brought into the assembly lines, the days are not very far where we see that in some of the cinemas, we see that, right? Or even some of the high-end malls, we heard that. You can say, you can go, you can choose your outfit. You can go and give a pose, and your outfit you can select that comes onto you, and you say, okay, how I'm looking. Oh, this outfit is not good for me. I will change it. So you can, but rather you can get a customization on that. Okay, I can say on the figure, I see, oh, okay, fine, this is there. No, this color, this black color, I don't want, I wanted it to be a dark green. I can customize that and I can send it for the production. So I get my custom dust delivered to my home. So it gets more customized to the end user. If I say a Bluetooth headphone I wanted, okay, fine, at present I'm having a Bose headphone or a Sony headphone, which gives, okay, Bose gives bass clarity more, but no, Sony gives more bass, but Bose gives more comfort for my ear. You can customize, say that, okay, fine, this technology I want, and this, finally you may get a customized headphone for you. Someone say, oh, this is ear cups are very big to me, my ears are small. You can choose the size and they can customize, build for you and get it delivered. What happens here? When you get it customized for your personal thing, you won't be replacing that very often. If I'm compromising on one particular aspect, but still I'm taking because I don't get the exact fit of mine, maybe 2 years, 3 years down the line, I may replace it. But if I customize it to my regular fit, we won't replace it so easy. That's our human tendency, right? It's a simple thing that like, if I am in a particular job for, let's say 10 years, going to a new job, it's likely we negotiate. The resistance will be there. Oh, no, I am here for 10 years now. I'm comfortable with all this. So why I want to take a change now? How would the new thing look like? What is the positives on that? So this gives, that's what environmental impacts come down. The recycling, the waste comes down slowly because I'm doing my customization for me. Similarly, improved sustainability. So when the less the waste, the more sustainable, the planet becomes more comfortable. We can optimize the resource. When the improved efficiency is said, we are reducing the usage of energy, or we are reducing the waste, we are moving towards more carbon neutral, we are going, and then at the customization, we are reducing the wastages. So both sides positive impact. Enhanced collaboration. That's what we said. We can, the more the collaboration that happens between the customer, between the business entity, between the manufacturer, the more collaboration that comes in, the more sustainable we become. Better decision making. This is one point that is going to change drastically. As I said, with more and more data available, real-time data. It's not a offline that we process. It's a real-time data which can be processed. The better decision making helps us. It can, now let's say with the real-time data, it's like I say, I'm in a manufacturing plant producing mobile. Let's say I'm producing some Samsung mobile. If I get a real-time data saying that what is the stock available in the warehouse, what is the real-time data that is available in the shops, retail shops, and what is the customer looking at? It's like how many pieces, if I can analyze it, the data forecast, if that I can do it, I will not be having a warehouse stock, extra warehouse stock will not be there. So my investment comes down. So when the investment comes down, the expenses comes down. So it becomes much more cheaper, much more efficient, much more, it's like the same energy can be moved to some other thing, which is very much required. So if I see recently, there is a lot of things, right? There is a lot of, what is that called? Equipment that is there, all the cars which were produced and they were in the warehouse, they are yet to dispatch. There is a lot of stock, which is where we have spent the energy, we have not about always the money, we have spent the resources there and still it is not useful. So we can do a better decision, which can be further helpful. Increased employee engagement. Now, as I said, if I see, if I go and interact with our manufacturing or some software developers or whatever the thing, there is I can sense is kind of dissatisfaction among themselves, working on the same field for longer durations. We felt dissatisfied. As I said, if you see my profile, I was into consulting, I was into manufacturing plant, I was into developers, I was into technology, I was into R&D, I was into customer. I was trading. So still I can say that I'm still happy to some extent. But if a person is on one continuous manufacturing chain, he gets dissatisfied over time because he's doing the same repetitive task day in, day out. But now if something else, a mission is doing the repetitive task, but you are trying to create some creative thing, it improves your mental wellness. It improves your mental well-being, the creative thought, which goes in a positive direction. The employee engagement becomes much more comfortable. See, as a professor or a lecturer, every year, same class, same subject, same teaching. I see my professor, who was retired now, who taught a kind of power system analysis subject over his almost 38 years or 40 years of his career. At the end of the years, okay, he has changed some subjects, and he was saying, Hemant, for our class, and he's about to retire, he was saying, my 40 years of career, I can say it in 4 parts. First 10 years, 1 decade, I can say as a researcher, as a young engineer. But then 10 years, I was into a teaching profession. It's like, he's not teaching, but the first 10 years is very more active into the research and things. But then next 10 years, he was into the teaching excellence. He became an excellent teacher. He molded because he has gone through the research, he has molded his brain, he got a lot of expertise on that field. He became a very proper professor, teaching guy. Then next 10 years, he says that I am a more kind of a management guy. He became into the management, dean, academics, he went to a kind of director level. And then last 10 years, he said, no, I wanted to give it back to the society. So he went into different directions. So he co-guided many theses. He wants more collaboration. He encouraged kids for doing multiple other things. So it's like go. So the employee engagement increases, creative thing comes. But if you are into single manufacturing domain, that over time it becomes problem. They lose motivation, that becomes a lot of other things, mental illness. So this helps us increasing the employee engagement. And as I said, enhance supply chain resilience because we are having smart missions. It's not always, we see that driverless trains, driverless metro. Recently, when I was in Denmark or Europe, there was most of the metros, they're all driverless. So there is no human intervention. It's all mission operated, a person sitting 1 or 2 in the control room, and everything is mission operated, nothing else. So that gives you supply chain resilience. The dependency, the transport dependency will be very much effectively managed. We are not driven by the growth of just mass production. Rather, we are going to be driven by innovation, new product, which helps us in our daily life, which improves our quality of life, which improves our mental wellness. That's where the sustainable innovation growth. When a growth happens with mass production, it's one kind of growth. You can see that kind of growth with China. But a growth that happens with innovation, you can see that kind of growth with US, where they grow with innovation, all kind of tech companies or what, that is different. The quality of life is different there. But when you grow with mass production, that growth is not sustainable for a longer duration. This helps, the Industrial Revolution 5.0 helps, where the mass production or all these will be handled by machines, but the growth is sustainable by innovation, the creativity. The human is going to be the center who dictates, I want like this, I want this customization. That helps the growth by innovation, which is sustainable, which, as we discussed about all other points, which is sustainable, environment friendly, human-centric nature. These are the benefits that we are looking at with the Industry 5.0. But which comes here with the challenges. Every coin has 2 sides. This comes with requires high skill. As you said, there will be loss of jobs at a lower level, which requires labor something, which opens up multiple jobs with creative mind. It's not always about studies. I said here it's creative mind. It's not about study. It's not about education. It's about creative nature. It's about skill that you have, which requires not a single skill. Okay, fine, I'm studying, I'm good at mathematics, I can do nothing. You can't get prosper things. You require across domain. Now, if you see the recent, the few job openings and the recent trend in a Twitter or LinkedIn, I'm not sure. They say Elon Musk has opened a role for a staff engineer for his SpaceX or something, where he says he don't want a degree or something as a prison. He wants a skill that matches the requirement. And if I observe the regular kind of schooling is also coming down. More and more of our policies are aligned to develop the skills rather than a formal education. So, but now the challenge is like we are able to create job, we are able to do for the one who are skilled, who are able to develop the skill, who are highly skilled professionals. That is a challenge, big challenge that is going to be. And all these advanced technologies that are getting created, the embedding of these technologies in the production lines is a bigger challenge. All the industries has to adapt themselves for those technologies to take forward, which is also huge. It has its own implications on the money. At the end of the day, whatever we say, right? We speak everything. At the end of the day, paisa mein Paramatma hai. Right? So everything comes to one knot and ties there. What has to move forward as one of the movies that we see, right? What we wanted to see or what we wanted to use is decided by someone who manages money somewhere. So they promote, it's a movie, right? Dhruva, yeah. It's a movie called Dhruva. He says, the hero says that what you wanted to see on the first page is decided by the people in the business page of the newspaper. Who rules the business page decides what you wanted to see. Whether you wanted to see a cricket headlines or you wanted to see a disaster on the headline, everything decides by that page. So it's all paisa mein Paramatma hai, which runs the show at the Globe. So the advanced technologies adaptation into the system is a bigger challenge. That again says additional, that says there is a huge cost that involved in training the human resources of using the technologies or developing the technologies. It's like there is a huge cost that is involved, which is not so easy. And finally comes the security with lot of data, with lot of control, with lot of smart missions. The security is always a concern. If something goes wrong, it may have adverse impacts onto the human life. So that is also a bigger challenge. And the fast and highly efficient manufacturing. As I said, if we improve one part of the production line, but the decision making is still lagging, let's say, it may result in overproduction, which loses the thing. Now, as I said, mass production, it may become mass production if only one side of the production line gets improved. If there is a closed loop with what is the, as we said, what is the demand versus supply closed loop, then it's some way. It's highly efficient. But if the closed loop response is missing, control system engineer can appreciate it, right? When there is a closed loop, it's more stable. Open loop system is highly stable, but fine. With a closed loop, we get a desired response with sheet-state lagging. So that is very much a challenge. And last but not the least challenge is like how autonomous systems can incorporate ethical principles. As a human, we know what are ethics. It's a kind of a robo cinema, right? Robo 1.0, first robo cinema. Feelings were induced into a robo, and then a red chip from Bora, how it changed. There are no ethics, right? So it's like how the ethical principles has to be incorporated. It's a bigger challenge with more and more missions. When we say collaborative robots or collaborative smart missions, how the ethics has to be incorporated. It's a big challenge for a sustainable growth. So these are the challenges that needs to be addressed along with the benefits that we're going to get, but this is the one more challenge. So when I say these are the opportunities, we say binaural beats, smart infrastructures, we can get a clean energy like wind, solar, battery, we can manage clean energy, intelligent transportation, driverless cars, driverless metros, we'll get with more of intelligent transport, smart clothing. I said, right, we can design our own cloth. Okay, I want this color, I want this style, I want this design of thing. I can get it customized for my. These are all the opportunities we're looking at. We have futuristic, but we have limitations here with information security. As a consolidation, human mission collaboration, how ethical it's going to be, how seamless it's going to be. Adjustability with more and more technology coming in, how everyone, it's not a single highly educated, skilled one is going to benefit. It's not that case. As we say, speak about sustainable growth in the industry 5.0. Every nook and corner of the globe has to get this benefit. How to adjust. A 70 or 80, 90-year-old, my grandfather who is 95-year-old, he also should be able to get benefits out of it. How he can adjust with these things. And then with the present day only, we are seeing a lot of scams with your Aadhaar-enabled payment systems, but then forensics, everything is going onto public domain, Aadhaar theft, this data theft, so all these limitations we have. We require highly skilled labor workers. And so what is happening? What is the futuristic opportunity that we're looking at? Hyper intelligent network. Everyone should get the leads. It's not so easy to break anything or make anything. It should not be that. As I said, community driven blockchain. Ultimate security and trust. We need to build it. Quantum computing. So when we say 6G, 7G further with high and high bandwidth, high and high missions, we need to do more computations. At the end of the day, it's all like how fast I can process the data to the information. See, a lot of data is useless. As long as data is processed and converted to a meaningful information, which helps in making informed decisions, helps us. Or else it's all waste. All the data that we collect is waste. So that's where these are the future research topics that one can look at. How we can bring in more security into the system with more smart missions coming in, robots coming in, how we can make ourselves foolproof. So at the end of the day, humans should not suffer. Rather, technology has to take us forward, not the backward. So these are the limitations, opportunities, and future. And as a slide for future direction, I say cognitive computing. See, there is difference. One is quantum computing, where we can probability of a state before it is measured. We are predicting the future, kind of. Advanced real time. Until now, we may think about real time, but it's like earlier than real time. That's quantum computing. Cognitive computing is like the human brain. Our thought process has to be gone into computerized model so that we can see how ethics can be built into the system. Because as I said, one of the most important challenge is ethics. Bringing in ethics into the thing is a bigger challenge. with more and more missions comes, and then finally if it disturbs our thing, we are not here to disturb ourselves. So how to get these thoughts of human stimulations into the computerized model, and how the human and machine interaction comes more and more collaborative. I can't ask my grandfather to guide a robot saying that you speak in English or Telugu saying that you get. No, it should be able to get to the end. Even the human gestures has to be able to get controlling the robots or machines, whatever. So to that level of sophistication we are looking at. If you see the present level of automations are kind of small robots or drones that we are looking. I heard in some of the Amazon big warehouses, there are kind of humanoid robots already working in place to sort the warehouse. If there is an order it comes through a barcode and its corresponding things, and a robot goes and assembles it and sends it out. So it's kind of slowly we are penetrating into it, but humans are already getting aware of what are its challenges that comes along with the opportunities. So we need to work together in a collaborative way to overcome the challenges. At the same time, we need to foster, adapt the technology for a better future. And I'm open for discussion or something, and thank you. Harish, I think so.
Yes, sir. If anyone having any doubts, you can ping in the chat box. Yeah, thank you. I think so. No participant was responded for this.
Okay.
Thank you, sir. We extend our sincere gratitude to Mr. Hemant for enlightening session on Introduction to Industry 5.0 and its human-centric approach. Your in-depth insights and engaging delivery provided participants with valuable understanding of the topic, setting a strong foundation for the program. Thank you for your contribution. Thank you a lot. As you had given good examples, which is combination of your electrical industry also, they have used there. Thank you. And now, yes, sir. Now I'm moving for section 2. It's my privilege to introduce Mr. S. Hemant Kumar, who will be leading this session 2. Mr. Hemant Kumar is an experienced embedded developer and trainer with over 10 years of expertise in embedded system. He specializes in PCB designing, controllers, and robotics. Currently, Mr. Hemant is serving as an embedded developer at DataPoint IT and Hardware Tech Private Limited, where he has contributed significantly to the development and testing of several high-impact projects. As a passionate educator, Mr. Hemant has conducted numerous workshops and seminars on PCB designing, controllers, and robotics across colleges in Andhra Pradesh and Telangana. With a decade of hands-on experience and a deep commitment to sharing his knowledge, Mr. Hemant Kumar has rightfully earned a stellar reputation as both an embedded system professional and an educator. So please join me in welcoming Mr. Hemant Kumar for this insightful session. Thank you. I request Hemant Kumar sir to take over the session.
Yeah, thank you, sir. So good evening, everyone, and welcome to the today's session. I'm Hemant Kumar Sunkara, and I'm honored
Sir,
to be
please
speaking.
switch on your camera, sir.
Yeah, sir. Just a second, sir.
Yeah.
Sir, is my audio, is my video is visible, sir?
No, sir, not yet.
Yeah, just be answered.
Yes, sir.
Visible to you?
Now it is visual. Yeah.
Yeah.
Now it is visible.
Yeah, sir. So good evening to everyone. Welcome to the today's session. I'm Hamad Kumar Sunkara, and I'm honored to be here with you all regarding about today's topic. And it's pleasure to share my experience and insights with you, with the eminent people, faculty, and the educators. So let me share my screen and start my presentation.
Sir, session 1 feedback link పెట్టేయండి sir. Hello.
Yeah. So welcome to the introduction to the MS systems. So is my PPT visible to all?
Yes, sir.
Yeah. So let me start my presentation. So welcome to the introduction to the embedded systems. So myself, Hamad Kumar Sunkara. I'm from embedded engineer from Data Point Solutions, Hyderabad. So I've been expertise in like PCB designing and embedded systems from the past 10 years. So let me give you like every expert like once a beginner. So nothing is nothing but when we create anything, when we want to create anything, we must know regarding about how to create it. So every expert is must be a beginner from a topic. So let me give you regarding about agenda. So today agenda is nothing but embedded system definition. So embedded system characteristics, embedded system applications, embedded system design. So processing engines and microprocessor and microcontroller. So let me start the presentation regarding about what is a system. So system is nothing but the is a set of principles what we need to follow. So nothing but embedded. So whenever we ask anyone regarding about what is embedded system, so everyone will share regarding about that it is a combination of software and hardware. So right. So let me give you some more clarity regarding about it and all the system that contains one or more processor to do a specific functionality and give a response is nothing but a software and a hardware, because every hardware component must work principle with a software, because when we move any item, like when we move a controller, or when we want to move a task, nothing but when we want to do an operation, we must write a code, right? So that's why it is nothing but embedded system is nothing but a combination of software and hardware that is to perform a specific task. So then we will give you some sort of clarity regarding about what exactly. So nothing but so everyone will say regarding about that a personal computer can be considered as an embedded system. So as it is integrated with hardware and software, right? But exactly the PC can't be considered as an embedded system because it is uses general purpose processor. So the system inbuilt independently from the software runs on it, because actually our embedded system is nothing but a combination, nothing but software and hardware that performs a specific task. In the computer, it is a perform the multiple tasks, nothing but like do several operations, do several tasks. So it is not exactly the PC is related to embedded systems. So let me give you some sort of inspection regarding about what embedded system characteristics. So reliability and efficiency. So another in an embedded system application such as TV remote control and the compact display will result in the product does not work and consequent does not well. So nothing but like when we are working in when we are going in a like car automatically, when we are going in a car, because when we are going in a car, when we have a met with an accident, the system need to respond immediately, because the system need to respond immediately so that that can save the man's life. So automatically it's like the efficiency of the system and the reliability must be very 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 accurate. So here some of the embedded systems may have the real-time performance constants that must be met for a reason such as safety and usability. right? So regarding about the tightly concerned regarding about the hardware resources, the power limited and the cost and the size, and regarding about the processing, regarding about the memory, regarding about the storage. So not exactly like regarding about the hardware resources, like what are the components we are using to prepare the system. When we are flexible, when we are having to do a desirable task, we need to have some sort of components, because as an embedded engineer, when I'm going to do a particular task, I need some sort of components, because sometimes we need a specific component do a specific task. Nothing but like the component what we are getting selected is nothing but to do a specific task. Sometimes the components might get some sort of values that will be not getting the operation on time and on done, right? When we need to collaborate and we need to mix up with the processor, controller and everything, we need to know the exact component ratio, the exact working, and regarding about the power, regarding about the size, regarding about the limitations. Because nothing but when we need to do that every operation in a set of way, we need to know regarding about how to do and how to execute in a such a way, right? Then regarding about the single functionality, and then nothing but the dedication to a perform a specific function, and includes the process dedicated a specific function. Nothing but when we do a task, that is nothing but a single functionality, nothing but in a washing machine. When we open the washing machine and we pour the clothes and we have turn on the steamer, nothing but when we mix the powder and everything, it is a single functionality. Nothing but it do the operation, and after the operation it will be getting the reset, nothing but rest, and then we go on the same operation, nothing but a single functionality. And when we go to the complex functionality, I often have to run sophisticated algorithms and multiple algorithms, nothing but algorithms, cell phone, automotive, etc. When we operated with different aspects, nothing but different ratios. And then regarding about the safety, and safety is nothing but must not be the endanger human life and the environment. And regarding about the safety is very critical, because embedded systems must contain must contains of a processor, controller and a unit that runs with the power, right? So mostly we need to endure the human life. The safety is some sort of critical. Regarding about the ability, the maintainability is nothing but the human, the ability to modify the system and after its initial release and enhance the performance, like execution time, code and memory size. So am I audible to everyone? Hello?
Yes, sir.
Yes, sir.
It is audible,
Yes, sir.
sir.
Yeah, sir, my screen is visible to everyone, right?
Yes, sir. Yes, sir.
Yeah. Right. Regarding about the maintainability, the ability to modify the system after its initial release and enhance its performance, like execution time, code, memory size, and automatically when we want to execute the code, because when we want to perform a task, we automatically write the execution time and the code and the memory size. Nothing but when we want to do a specific task to a specific processor or a controller, nothing but when we want to do a particular task, we need some sort of execution time and we need to write the code when we need to have some sort of memory size and the ability to perform the task. And regarding about the interactive system, an embedded system should be very interactive as possible, so that is easily understandable, operated and handled by a user. Nothing but the ease of task. And what I mean to say is, like, when we do the task in a such a way that the system can understand and the system is can fluently working in a ease, like fastly moving term. So nothing but, and let me give you comparison regarding about the embedded systems and the general purpose systems. And here in my slide, I'm showing you regarding about the how the embedded system is and how the general purpose system is. Nothing but the embedded system is not programmable by the end user, because we already done the programming, and because when we start the system, it's already programmed. Because when we start the system, it's already pre-programmed. Because when we on it, it's already have a program. Start the process. Nothing but when you open like a when we open our when you go to the ATM and you're having a like when we insert the card, it is cyclic process, like insert the card, it having the keys, and we insert the card and we have a keys, right? When we go to the keys, we have the user, nothing but your name, like account holder and bank details, like it is a cyclic process. So like that, and the general purpose is nothing but lot of applications, and it is a not in a embedded system, it is a not programmable by the user. And in the general purpose system, where we are programmable by the end user, because the end user will give the commands to control the total system. And regarding about the criteria in the embedded system is nothing but a cost, power consumption, and like a size. And compared to the general purpose system, it's not the cost and average speed, nothing but. So regarding about the embedded systems applications. So let me give you regarding about the embedded systems application is nothing but automotive, telecommunication, the electronic devices, computers, home automation, industrial, aviation, banking, and robotics, cinema industry, medical equipment, a lot about like etc. Like we have so many. So let me give you regarding about what exactly in the automotive. When we open the like when we have a car, nothing but a normal car, it nothing but a lighting system and the airbags and the ABS and parking system. And normally when we know that car is we have seen so many cars like we have used some like Duent cars, like we have a presently we are having sort of like upgradations cars, nothing but Tesla, everything, some sort of cars in which we have embedded systems in which like the main motive, the principles of the system, because every system having a some sort of very very important devices in which the automotive devices in which the embedded systems is nothing but the lighting system. It is the main system where we used in the car, nothing but the airbags. It is the main reason because it is the main cause to save the human's life. So that is nothing but working by the embedded system. And we are having the parking system and we having the ABS, totally nothing but automotive. In the automotive industry, nothing but cars. In the computer, you will find the sound cards, Ethernet cards, and the graphic cards, where you people already seen regarding about the sound cards, Ethernet cards, and the graphic cards. And in the washing machines, nothing but the electrical devices, nothing but washing machines, micro ovens, the water heaters, and the like dishwashing machines, air conditioners, TV, LCD. These are the so many devices where the embedded systems are being used. Like let me give you some sort of clarity regarding about home automation. Like when by like the totally the world is automated, like everything is integrated with our mobiles, everything is integrated with our devices, nothing but the controller what we are using, everything is integrated. Like hope we you all know like already in the session, like in the before session sir already told regarding about the automation, like hey Alexa open my door. This is nothing but the automation which the controller having already predefined commands. We already given a command called we will give you some sort of keys that ends to an operation. Because when we write the code, we will give already some sort of keys like how to open it and how to close it. Nothing but when you are having automation, like presently the homes are very trendy. All the homes, like everything, the fan, the AC, the actuator, nothing but the smoke detectors, the power, everything. Because when we having a mobile, the mobile will when we having the mobile automatically give the operation set in which we will can monitor the fans, mobiles, lights, everything. Like we can monitor our every inch of like our home. That is nothing but by using the embedded systems only. And let me give you regarding about the clarity in the industries. Like industries are automatically embedded, like the factories which having a huge robotic arms which can assemble the car components, like any other missions, like so many. So that the huge components being used, the embedded systems are with huge components because they prepare the testimonials and they prepare the real-time devices in which the large equipment, the placement, the like the size, the variations, everything will be done by the industries. Like in the military you will find like regarding about the tank shooting systems and the submarine systems and the missiles and the target identification systems, so many. Like the people being we use embedded systems in a such a way that it is a very 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 important source in such manner. We use the systems that can be created with a pattern that can include the system where with a software and hardware in the military also. Like give you in like telecommunications, like we have mobile communication implementation, the 3G, 4G, and we have in the Wi-Fi chips, routers, switches, everything. Like when we created a system that consisting of a pattern of a like a task to complete the task like in different ways in the applications in the telecommunications also. And regarding about the aviations, already I informed regarding about the navigation systems, because we have some sort of planes that is nothing automated planes, because which doesn't have a driver. The plane automatically creates its path and can travel in such a way with a GPS coordinates, can travel from this coordinates to that coordinates and then get the information from sort of sensors. That is nothing but through embedded systems only. We can we're having a GPS systems, we're having a satellites, which in satellites we have received so much of information. Like we can get the information regarding about one end information, what is going on, what is the what are the precautions, like what are the existing system, like what being we getting the some sort of information from different analysis. let me give you what is the robotics. And robotics nothing but for any for a purpose like homemade gun, like homemade or industrial, and playing security, nothing but in different aspects the embedded systems are used. Because you see the robotics, nothing but we created a robots that create that can give you some sort of information, whether the information is also predefined, because we already give an instruction set. Already you seen in different movies regarding about like Chitti, that is giving you some sort of instructions is nothing but already they created a set of instructions that is given. They feel like the instruction set is already given. When we give any command, it automatically go to the set of command and automatically create an instruction set in which very similar instructions also they can give the reply. So that is like the already the embedded systems is created in a such a way that created a good pattern where can robots we can create with the embedded systems also. And nothing but the banking, where in the money counting machines and the ATMs, nothing but in ATMs also we use embedded systems where we get the some sort of information like the count of the notes, where that is a code given. That is an embedded system. So that is nothing but embedded application in which we have using the cinema industries like cameras, theaters, and the motion effects, where you need where you created so many recently we've seen so many movies and the Bahubali, that the way of expression, that elevations, everything, nothing but they created a pattern in which the animation effects in such a way that the system that created in a good animation by embedded systems only, because they created a code, everything they given a motion poster, they given some sort of values where they created the animal in a such a way. So in the cinema industries also we use embedded systems. And in the medical equipment like ECG, in the diagnostic tool that measures the records and the electrical activity of the heart, like a ultrasound in fitness devices, in the cardiac pacemaker, and the nothing but the devices which created a pattern already consisting of embedded systems, because they can take the values of the system and they can check the values which is similar data sheet, and they give the prediction that prediction is nothing but they give the accurate solutions. So the medical equipment also we use the embedded systems. And in the wearable glasses like Google Glasses and the smart watches, nothing but when we have smart watches, we created that was created with by using embedded systems, where we have SpO2 that measures our body heart rate. And nothing but when we do several operations, like when we do walking, and when we that will count the create how many step count, everything that includes our parameters also, that is created by the embedded systems only. And the temperature adjustable clocks also, because some sort of people who've been working for our in different areas like in the Jammu and Kashmir regions, where the temperature is like in the high values that will not good to the human, so they can use the temperature adjustable clocks also, because so the temperature is very minimal, that is created by the embedded systems only. So let me give you regarding about the how the embedded systems is designed, like nothing but how we need to create the design. And that in functionality between the creation, the trade-off between the software and the hardware, and in which one with the functional block should be performed in the hardware, and the second which the functional block should be performed in the software. And in the hardware and software, nothing but the two creations that will get an output, nothing but when we give a command, and automatically the reactors, when we give a command to the controller react. So the controller react and give the accurate inputs, nothing but when we give the inputs, the controller can give the output. That will nothing but an embedded system, nothing but it is a combination of software and hardware. So in which I will give you further clarification regarding about the functional blocks in should be performed in the hardware, and the second topic is nothing but should be performed in the software. So let me start regarding about the software. In the software, we have the advantages like highly configurable, and the shorter development cycle, and the easier in the version updates, nothing but cheaper, because we use the software very heavy configurable, and the short development life cycle, because we need the write the code, and easier in the version updates, because we need to get the versions updates easily. And the disadvantage is nothing but the constant with the processor speed, which may satisfy the real-time applications and may not, because sometimes we may not satisfy the real-time applications, because due to the like large span issues, because sometimes the system may not satisfy all 100% of the customers. Because when we created a product, nothing but when we have Tesla, nothing but let me give you an example. You all know regarding about Tesla is a better car, like best car, what being used by the people. When the Tesla is used in the US and other areas, compared to the Tesla into the real time into the different cities, So it may not be functional in some sort of cities, because some sort of cities may not have that parameter, nothing but the road, the actual values may not get. So Tesla is nothing but automation, like automation test drive. Sometimes it is automatically having a predefined instruction that will drive in the from a certain step to certain set, from some distance to some distance. So like that it can travel in some other place. So in India also we can use it, but some sort of areas may not get be used. Like that is not the disadvantage, nothing but some sort of elements may not satisfy the equation, right? So let me give you regarding about the hardware characteristics. And the hardware characteristics nothing but the better performance in the high speed real time application, and in we use different types of controls and different types of gadgets, nothing but different types of pins, elements, allocation, everything. And regarding about the disadvantages is nothing but the longer development cycle and the customized for specific application, not updatable. Nothing but when we use a predefined, nothing but when we have a controller that consisting of only one operations, when we are using the controller for a particular operation, we can't do the separate another operation, because the particular the controller or the sensor or any other item is only predefined for a one particular task. So like that, there's a disadvantage that we can't have multiple options in it when we use a minimal component or when we use a single component. So that is the disadvantage in the hardware. And let me give you clarity regarding about the hardware and software positioning and the design to build the target hardware, nothing but the first point, and the development of software independently. And regarding about the integrate them and hope it works, nothing but when we create and build the target hardware, normally when we create the hardware, we must check with the values, because when we created the hardware, it consisting of a positioning where we need to position, where we need to accurate the values, where we need to get the accurate code implementation, development, analysis, everything we need to check, nothing but how actually it is working, and integrate them in such a way that it will work in order to get the solutions. So let me have the regarding about the embedded system design steps. So nothing but when we modeling via a modeling language, nothing but LabVIEW or MATLAB, and where we need to have some blocks, like where we need to have hardware and software much having a global design for a software, and the unit design, nothing but how to create it, and we need to rewrite the code, we need to having the testing, nothing but for every single step we need to test, and we need to verify and integrate and then test. We need to having another step called we need to integrate, because suppose if we want to create a system, like when we want to create a system, we need to move the system from one end to another, nothing but a robot. So we given a code for the motors, nothing but we need to create a code. The code automatically gives a instruction called the motors to move the front board, nothing but the motor can move from one end to another with a two motors or a four motors with a command already given. The processor is nothing but continuously command. The motor is moving towards the path what we already created. So nothing but the integrate, nothing but it testing. We need to integrate every component, and we need to test some sort of component, some sort of errors may occur. We need to verify it, and we need to compile, and we need to verify the code. And after the verification and validation, we need to maintain some sort of power, because we need to have some power. We need to maintain some ability to perform the task in such a way, so that the embedded system design tips. These are the embedded system design tips. And next, regarding about the embedded system design challenges, where we can perform the different tasks that the requirements are satisfied, because it can perform the computation such as the requirements are satisfied. The embedded systems perform the software that are subjected to the physical constant, nothing but hardware. Already, when we write a code that is created, that is to perform the task, that is nothing but that are subject to physical constant, nothing but that is all interrelated to the hardware itself, because when we take a different component, the code also might get some sort of change. So that will be work on. And the execution on the physical platform, nothing but the processor speed, power, storage, and reliability. These may occur because some sort of processing speed may be the issue, and the power, some sort of power, because when we make them in a bigger way, when we want to them in a bigger way, some sort of power issue and storage issues also occur. And the reliability, perhaps the reliability also. And regarding about the design goals, the performance, nothing but the performance, the overall speed and the execution of the time throughout the output, because the functionality. And normally when we design, we need to know the manufacturer codes, because every every item that is created by manufacturer. Suppose give you you can already know that different manufacturers. Suppose we know regarding about the pen drive. So every pen drive is created by different manufacturer. We have a pen drive from we have a pen drive from HP companies. When we have a pen drive from different companies different companies, they created a pen drive. So every pen drive is unique because they having its own patent, because they created the design, they created having the functional unit, they having patent and everything, because they already having a design goals, because they created every company, they created in a such a way that the other company may not be actually get into the same values, because so that is a design steps, because they need to follow the functionality and the user interface and the manufacturing cost also. Sometimes the company may get some sort of manufacturing, because when you are familiar with some sort of mobiles, when you see the different mobiles, when you compare to the mobiles of Apple compared to the iPhone with the normal phones, because the manufacturing also some cost may be occurred, because the devices are some sort of similar, because the manufacturing unit may contain some sort of different steps. Because compared to the two phones, when we have a two phones, like a normal phone, nothing but an Android, and compared to the iPhone having a separate unit. You know that iPhone is like a different series with a cost of 1,26,000, that consisting of a different, because their own unit, their own manufacturer, compared to the normal phone like Vivo, Oppo, because they created a pattern that consisting of a different elements from a different companies. They take the different elements, because they take a battery from another company, they take the chip from the another company, they take the processor from the another company. They just integrated all the components in it, and they just created a device within a 2 to 3 months or 6 months. But compared to the iPhone, it is a different, because the manufacturing goals and design goals are very different. So that is nothing but the power consumption, the safety, and the other requirement, nothing but physical size. And regarding about the system on board is nothing but where we created, because automatically when we created to design a chip, when we created to design anything, we know how to we need to know regarding about the size, we need to have a regarding about the overview of how to create it, we need to regarding about we need to execute, and what we need to going to be executed, and what we need to be presented. Because in system on board we need to know everything regarding about. And then regarding about the system on chip, in which we have a different controllers, different system with different elements what we basically use. And regarding about the microcontroller, you all know regarding about the microcontroller, nothing but described as a computer on chip, a single chip containing a CPU, nothing but RAM, ROM, and a timer and a control unit. So microcontroller is nothing but is a component usually included in serial communication, nothing but where we created with the devices. Normally used in the different devices where we use with the hardware setup. When we use already, I'm already in the before slide. I already taken an example like nothing but a IoT device where we having a home automation. The embedded system is automatically connected with the IoT device. Where we created home automation with IoT device, nothing but Node MCU. When the Node MCUs want to work, we need to have a serial communication. Nothing but input and output peripherals may connected with the receiver and transmitter at the serial communication. Automatically, the data can send from the server automatically to the embedded system. So that is created by using the these terms, and use it for the dedication operations that may be designed by the system engineer. And regarding about the microcontroller, as we having a oscillator, as we having a analog to digital converter, and we having a ROM, program memory, in which the microcontroller does not work alone in the circuit. It must interface with another chip devices like sensors, switches, LEDs, LCDs, keypad, and DC motors. Nothing but it can't work without the circuit, because it need to interfere with the any other component, so that it can develop a task or it can do a specific operation. So that is nothing but a microcontroller. The microcontroller can accept the inputs from the some components and provide outputs with other components with any given system. When we need to create any task, or when we need to do any task, we need a microcontroller. We need to give the operation set, we need to give the task, and when we created it, automatically it give the output also with other elements. So the difference in the requirements make the manufacturers produce different microcontrollers with a different memory sizes, the number of the input output lines, and the number of the integrated peripheral devices, and otherwise the similar where they use similar, right? So this is regarding about the microcontroller. Let me give you regarding about the microprocessor. It is nothing but a CPU which having a add memory and the clock input output interface, the timer, and all other needed peripheral. This is nothing but this is a session. The microprocessor has so many pins, because when we are connected with a different the difference between the microcontroller and microprocessor is the microprocessor is a general purpose computer, while the microcontroller is a computer dedicated to do one or just a few tasks. Already in the previous slides I am already explained regarding about the microcontroller, nothing but different microcontroller. So in the present task I'm just comparing the microcontroller and the microprocessor. You can see the difference between it. And regarding about the CPU structure, the basic elements of the CPU is nothing but a arithmetical logical unit and the responsible for perform the logical tasks, and nothing but the arithmetic calculation, nothing but you know all regarding about it. And regarding about the basic elements, nothing but the FPU, the floating point, perform arithmetic operations on the floating numbers. And regarding about the registers, what we registers are usable to store the data. Besides the ALU, the registers are like transfer the information data from one to another. And the registers carry the inputs from the ALU as well as the receiving the outputs from the ALU. Right. Regarding about the CPU internal structure is nothing but a special bus. It is responsible for transferring the data between the registers, ALU, the system memory, and everything. And regarding about the control unit, you already know regarding about it is responsible for organizing the actions of the CPU. It can be thought of the heart of the CPU. And regarding about the architecture, you already know regarding about the two types of architecture. One is nothing but one human and Harvard architecture. It is nothing but have a single common memory space between the both the program and the instruction. Then the data is stored. And regarding about single bus in which both the instructions and the data can fetch nothing but. So this is nothing but one human, and which hardware is nothing but have a separate memory in which the areas of program and instruction can be, and one bus connected to the CPU to RAM, and the another bus connected to the CPU to the ROM. So this is nothing but the hardware and one human. And regarding about the difference between the advantages is nothing but the simplicity. It is nothing but it's just depending upon the speed and it with the more hardware cost. So regarding about the one human hardware. And regarding about the memory unit, because memory is a part of the microcontroller they use for the storage, nothing but a RAM or ROM. What is ROM? Nothing but ROM is nothing but read-only memory, and RAM is nothing but random access memory. So that's about the memory unit, and in which the memory, random access memory stands for the random access refers to the ability to access the memory cell directly. RAM is much faster than ROM because it is used to write and read the values in the programming. In the first session, RAM is nothing but a volatile memory. Volatile is if you remove the power supply, the contents automatically lost, and any variable used in the program it is allocated into the ROM. It requires external power to maintain the memory unit. It's nothing but the difference between the RAM and ROM is nothing but what you actually seen the user to it is the data storage in which the controllers the program may be running. Right. These are the RAM types in which we have a dynamic memory, a dynamic RAM and static RAM, and in which we have a ROM, nothing but read-only memory. Read-only memory in which the OTP, the flash memory, and these are the several types of ROM: EVP ROM, flash ROM. These are the types what is one-time programmable memory. If the microcontroller contains this memory, you can download the program into the OTP, but the process of the program downloading is one-way ticket. The meaning that can be done only once, because in the ROM we call only one-time programmable, because when we get the task we need to execute it. That's it. So that will be used in the different products. Maybe in the nothing but another topic called masked ROM. Masked ROM is nothing but the microcontrollers containing the ROM that mainly use the huge manufacturers, and the program is loaded into the chip by the manufacturer. In case the manufacturer scale of manufacturing is very, very low, the price is very low compared to the price is very low when manufacturer. The ROM whose contents set by masking during the manufacturing process. So programmed upon the microcontroller production, because the production is depending upon the masked ROM only. And the EVP ROM, the package of this microcontroller is has a recognizable window on the upper side. It enables the surface of a silicon chip to lit by a UV lamp, which has a result to complete the program cleared and the new program download enabled, because that is nothing but EVP ROM. It is nothing but EEP ROM, electrically erasable programmable ROM. The content of this memory may change during the operation similar to ROM, but remains permanently saved even if the power supply went off, similar to the ROM. According to EEPROM is often used to store the values created during the operation, which must permanently saved. This is regarding about the number system, that is nothing but decimal, binary, and hexadecimal. And this is regarding about the testing, where we need to test, how to we need to test. Nothing but the software process activities. firstly we need to write the code, nothing but a specification. The customer and the engineer define the product, because how the constants, nothing but when we all regarding about that, when we need any to do any operation or we need any product, we must see some set of rules, the product having a set of rules or a set of instructions that will be performed. So like that, the customer or the engineer define the product having a some set of operations constants. So then the engineer can develop the design, the engineer then develop the programming, and upon the programming they can test, and then they giving the validation is nothing but check to ensure the customer requirements, because whether the customer is satisfied with the product. Automatically every product every product automatically, embedded systems, every product is for the customers itself, because they created to evaluate the customer uses. Or automatically we see in the real times also, because you already know regarding about we created having Vande Bharat, because Vande Bharat we already have so many similar trains. Because let me give you some sort of example regarding about Vande Bharat. You already know regarding about the different times in the different trains already we used, like we've been used normal trains like express trains, and we having a super fast so many trains. But the government has created Vande Bharat, because they created Vande Bharat for not for like a like smart upgradation. Like they created Vande Bharat because there is a bug. So every in every rail you in every rail there is a, in every rail at the corner, in every rail when there is a curve occur, the automatically the rail is getting its high end position to the zero, because automatically the speed is reducing from 70 to slowly reducing from 10 5 4, automatically it's reducing in the curve. Automatically there is a bug in the India lives. So they created Vande Bharat to remove the bug. In Vande Bharat you feel that the Vande Bharat is when it is moving towards the, when it is traveling from the curve position also, the Vande Bharat is gets at actual speed only, it can't be reduced. So like that the customer, because the engineer must secure and must be checked to ensure the customer requirements, so that the product may be evaluated like that. So evaluation nothing but change to meet and change in the customer's market needs. As per the market needs, the company, as per the market needs, the company need to get regarding about the requirements. So regarding about the embedded systems, what actually is like, we need to know the how the engineer need to define it, and how the engineer need to perform the task. Nothing but how to we need to execute and evaluate, and whatever, nothing but the process is nothing but software process activities. And let me give you clarity regarding about the introduction to ML and AI on the microelectronics. So machine learning is a concept where we need to integrate the controllers also. So let me give you a constant example regarding about the machine learning. So what exactly machine learning is like, we having it is having a data, it is having a predefined set of instructions, we need to execute it, and we having a CSV files, everything. Like let me give you a small example. A small baby, let me consider a small baby which is doesn't have a sense lighting, but a small baby considered as a 2 or 3 years age. When he try to move towards the flame, because there is a flame put in on the on a table, and the small baby trying to move towards the flame. When the baby reaches automatically the flame, the baby want to put the hand, he just see the surroundings, nothing but his parents, nothing but his elders, he sees the surroundings. When they are responded, the baby see that there is a that will not be touched, and so that the baby can understand that it will be a flame, because he can't understand, because he don't have that much knowledge, because as he was a 2 or 3 years at the young age, he don't know. So the after the parent reaction, after the parent, when the parent is very angry and the parent is like shouting, so the baby feel that is a dangerous. When the parent is cool and study, the baby don't feel like. So that is nothing but a machine learning. What exactly the concept on perhaps of embedded systems. So nothing but when we the controllers automatically, when we create the AI, nothing but artificial intelligence with the controller. So artificial intelligence is nothing but the mission understandable language. What exactly is how to perform the task in such a way to execute the task. Already we have a set of operations. When we want to perform a task, we already given a set instruction set. The automatically the movement can be done. It is nothing but a robot, or nothing but a car, or everything. What exactly the AI and machine learning do? So machine learning is nothing but a predefined set. It's a set of values. So what actually we do means we already having a set of operations, what we need to execute, what we need to do. So how the microcontrollers enable the machine learning at the edge, and regarding about the benefits like power, regarding about the cost effectiveness, regarding about the real-time processing. So let me give you clarity regarding about what exactly the brief overview of AML. So it is nothing but the processing data locally instead of sending it to the cloud. So normally when we send the data, when we take an IoT device, normally we collect the data, nothing but when we get a when we take a sensor, nothing but already, and in the previous slide already I shown regarding about the home automation. So automatically when we off the fan, when we on the fan, that we created a server, nothing but when we created a application API keys, when we created an API key, we created a server. We created a server in which we get the two keys, in which one is for the read key and one is for the write key. When we already given a command in which when the person or the user given any command, the right command, automatically the right instruction get to the code. Already the instructions having a set. When we already given a set called on or off, whatever it may be, it can be done the operation, and the operation automatically stores and sends the same information to the cloud. Automatically the channel having the data in which what the user already given in every second of information, the every instruction set is already be predefined in the server. Because when we get into the cloud, when we get into the cloud like a API, and when we download the API keys and when we download the data, we will get in the export nothing as a PDF, in which PDF we will show that like what exactly happening and what is exactly doing and what exact the operations is going on, and what are the steps we followed, and with the time values also. So nothing but the every data is getting downloaded. So that is nothing but in the cloud. And in which the processing data is locally instead of sending it to the cloud, it enables the real-time decision making with a minimum latency. Is nothing but the already when we having a commands, we understand that normally basically the human can understand the commands, because when we raise a hand, we automatically get the command that the automatically our hand is raising. It shows that the hand automatically having a momentum in which the brain gets its operation, right? So the brain automatically having a minimal command to send the like my voice or my eyes, everything is nothing but an embedded system, because the brain is automatically working with a latency to wave or to get an operation. So like that it enables the real-time decision making with a minimum latency, nothing but. So it is having the real-time operations already performed in it. So we need to get some sort of values in which we need to get some sort of values. So normally get into the real-time task. So normally when the person is moving towards a minimum, when the person is moving towards some distance, so the person having a visibility, the person having a know the how to like everything, so the person can move. So suppose instead of that when we take in a blind person, or else suppose in that when we taken the person who is disabled or some, and the person who is disabled with we created a kit, we created some sort of device or anything. So that is nothing but the machine learning enables the real time decision making, in which the decision making in which the nothing but the processor already we given not normally in the embedded system we given a code. The code automatically performs whatever it may be the operation will execute. It will it will try to execute, or else it will go to the rest automatically. It's a cycle process. It will start, it will execute, done. Then if you on it will start execute, done. When you on it will start execute, done. It is nothing but a cycle process. But what actually in the machine learning it enables the real time decision making with a minimum latency. Automatically it's the the cloud automatically nothing but the system automatically having the real time decisions, and exactly the facilitates the privacy and reduce the network dependency. So automatically when we use the machine learning, the privacy like facilitates the privacy and reduce the network dependency. And in the ML tasks on MCU is nothing but a squatting in smart speakers, nothing but a predictive maintenance in the industrial IoT, and the gesture recognition in the variables. Nothing but when we created anything with the machine learning, automatically if nothing but if I am created a normally a device that is holding in my hand, and it is nothing but a robot in which on the other hand. when we automatically I given any instruction, automatically the machine learning in which it will sends the CV file, automatically at the other end of it, automatically the same finger will rise. It is nothing but the real-time decision making. At actual operation of the scenario, the decision can sense the information, and the information is exactly what we need to specify it, and what we need to do it, and what we need to execute it, that can be done. So it is nothing but ML works on it. ML actually works on it with a smart moves. Nothing but it can actually predict the values. It can know. Suppose if we're having a normally when we take a real-time data, nothing but when we take an image. Normally, if I am a person, if I am a very like I am a person, if I am sitting before you, right? So if I created a machine learning concept in which can you see my face like happy, sad, so already we given a already when we write a code, we need to have know regarding about the how the image is, and nothing but how the person having a minimal like how he smile, like how the person smiles having a, some sort of ratios, and the person having some sort of sad having a, some sort of ratio. So everything we need to like the real time decision making is nothing but when we created an embedded system. So automatically when we create an embedded system, we need to the user need to see it, because the user need to see it, and user already take the values in the machine learning. The automatically when we having a lot of data, when we having a predefined, when we having a set of data, the set of data will go on instruction set, and after the data getting executed, we'll get the accurate output. So like that, like it is very different, because when we integrate with the machine learning and AI with the embedded system, that is like very different, because actually you see like present era, like whatever it may be, the development of the present Indian eras, like we are going to we are going very smart, like we are upgrading everything, like we are going to upgrade our mobiles, we are going to upgrade our systems, everything. So little bit of upgradations is going on in every system. So like that also machine learning is a better concept. Like machine learning with AI, artificial intelligence, will make a better concept when we compare, when we integrate with the embedded systems. That will create a new device, the different devices which having the decision making skills automatically. So then let me give you regarding about the next slide. Nothing but artificial intelligence. So now automatically the stimulation of the human intelligence in the mission. So normally the human think, the way the human think, normally the human having some sort of issues, because how to express it and how to deliver it. So like that, when we created with artificial intelligence, also the robots, or like the missions, or like the testimonial devices, what we are actually going to the in the operation set, what we are actually going to be operated in different sets. Suppose if we take a mission, normally when we take a different when we take in the industries, so industries you see that lot of laborers is working, like in the like car industries, in the normal in the personal industries, like some sort of troubles, because when we created a human intelligence, when we created the AI missions automatically do the same task, because sometimes the human effort, sometimes the human failure, so human effort and some sort of issues, like when we created when nothing but in the COVID pandemic also, we see a lot of people who was a lot of people are being troubled with the uh, due to some issues like the health issues, or automatically because the era automatically the industry is also kept shut down for few days. Automatically when we having artificial intelligence, we created the different missions, automatically the industry will be booming, the missions maybe work automatically. And there is a disadvantage that the reduce of the human efforts may be occurred, but automatically at the end of the day, in some critical situations, like when we having a bomb explosion, when we, you know that already people like when there is a bomb explosion or any other place where the human where we need to have the AI robots or like machine learning robots instead of humans, because human where with the human will go and have his life in a critical situation. So that we use these missions like AI and machine learning also, like in the defense also, when we created a devices, we can use it in the defense also, in the defense in such a way that the defense organization, so you know the military purpose, whatever it may be, we can use in a such a way that we can extend the importance of it. And regarding about the machine learning, a subset of AI where the system learn and improve the data without explicit programming. So not automatically nothing but when we already given an instruction, nothing but it can learn and improve the program. When we created a data, we can we can already the missions can't even learn. The missions does not have operations. When we given the command, when we given a command that the hand have 4 fingers, the machine automatically understands the hand have 4 fingers only. When we given in a such a way that command, automatically the machine improves the data, improve from the data. Already we given a data to the machine to perform the particular operation. So the data which we are giving without with the programming, like whatever it may be, the programming we done from the machine learning. So automatically what exactly the machine learning do, the machine learning automatically get into the data. It will check the data with the subset of the what we giving. So we automatically we know how to actually suppose if we take any example, suppose if we take any system or else any embedded system, what actually it will do? It will do the programming, it will do with the user manual, it will do with the user automatically. So every embedded system must contains the user instructions. The user need to come and user need to get into the instruction, or else the user need to get instruction from IoT or nothing but any other devices. We need to some sort of instruction will be done. What exactly machine learning is? Machine learning is nothing but whatever the data we are going to be export, or we are going to be give the data, the machine understand the data, and the machine understand the data and give the subsystem operations. Because when he understand the data, when we given a, for example, we take a paddy land. What actually do the paddy land? When the farmer go into the farming, in the he plug the land, everything, and when he need to insert the seeds, everything, what exactly, like he need to do the operation from the one operation to second, third, fourth, fifth, every operation. When we have a set of data of what to do in the fields, when you give the same data with the machine learning robot, the robot automatically do the same operations. So automatically the robot can understand how to do the task, because we need to create it. And already you know that the everything, like whatever it may be, when we do the operations, we automatically know that how the operations can be working on, right? So every operations, nothing but every operation what we actually do in the system. So every operation what we actually do in the system is nothing but the system mission devices. Suppose if we take any object, the classification, like if you move the devices from one end to another, if you move any programming part, nothing but if a controller, if we take any processor, if we take any device, so every device, because in embedded system is nothing but when we created, the devices are created to do the perform task. Perform task means we take any electronic device, every electronic device that consisting of embedded systems, and whether we created the machine learning, whether we want to create it with the machine learning, that is nothing but a data in which we need to give that, because the user give the instructions in which the data may be the predefined data or the current data or the existing data, because sometimes the instructions are already predefined, because it is nothing but when we give this data, when we give the data and then we give the instructions, the data and the instructions will get collated, and that will be work on. But automatically when we when the user getting the new data, but every real-time operation, nothing but when we send the data with a different operations, automatically it will be work on. So like that, we need to present, like we need to understand that machine learning is very industrial, in an industrial view, so that the it will be a different analysis. For example, like in examples, you already seen regarding about the image recognition. Image recognition automatically, you already know regarding about your mobile. When we open the mobile, automatically the image already recognized. Image already recognized, and automatically the face analog will be opened. Right? Automatically, how exactly work on? Say every image is converted into the pixels. The pixels, every image is converted into the pixels. Actually, the pixel ratio is just equal to the what the image we are being taken, because already we having an image taken by the phone itself, in which we have been stored, and automatically the new image, so it is a equal ratio where when it is equal, automatically the phone will be opened. So, and the natural language programming and the predictive analysis, nothing but everything is predictive, and we need to predict normally if we normally let me give you regarding about the data, like what exactly I mean to say is regarding about data. So data is a main thing in the machine learning concept. Suppose already you shown people see regarding in the different movies regarding about that in a movie called Boys, where the person who is having a data, in which you're having a book of data, in which in every in every temple they eat some kind of prasadam, like that prasad. So like that he having a data, so that the data is very very important. Like that when we get into the actual real time working of the embed systems with machine learning, we need to get some sort of data. So actually the data is working, and that the data given is whether the data given with the good inputs or not, whether the given data is actually working with a predictive analysis. Is nothing but a predictive, is nothing but yes or no, or what actually is whether we given the data maybe yes or no. Is predictive is nothing but when we compare to the real time working, is if we compare to this is a hand which consisting of a 5 fingers, in which we created a path called A B C C D E, and compared to the data sheet, where in the data sheets also I created a table, or else I created image in which I created A B C 5 pattern. The data set is equal to that, it is nothing but a predictive analysis, nothing but predicting yes or no. So automatically machine learning and AI, artificial intelligence, in which the significant feature is nothing but is predicting maybe the yes or no concepts in the similar ratios. So the applications in the everyday life is nothing but the smart assistants like Siri and Alexa. So Siri and Alexa is nothing but automatically when you people see like hey Alexa open my door, hey Alexa can play a song, or like everything. So when we give the command like hey Alexa play a song, so the Alexa is get the command and play the song. So it is having some sort of decibels, right? So some sort of decibels regarding about it. Actually, so some sort of decibels of sound actually may get some sort of decibels of sound, right? We can so the IoT actually the IoT can meet the real time applications really in the different mode. Like when we created a things, when we created a pattern of devices, what actually is when we integrate the AI, when we integrate the AI with machine learning concepts, automatically we'll get different sort of inputs. Nothing but when we having a ratio of inputs, when we take a similar concept in which the predictive analysis, nothing but when we take a system in which nothing but home automation already know, you people already informed me regarding about which, in which already I given an example with Alexa. So Alexa is taking that, hey Alexa open my door, the Alexa will automatically open the door when the decibels is equal to the ratio. When the decibels is not equal to the ratio, the automatically the Alexa also can't able to hear it, right? That means the data sheet already what we given is having some sort of values that we need to be accurate. uh, so like that what exactly is like when we integrate some devices, some different devices, the basic requirements is nothing but when we need to create AI or machine learning with the controllers, we need to have some sort of ratios. What we need to nothing but the working principles. What exactly I'm saying, that the working principles when we created the machine learning or AI with electronics. Firstly, let me give you an example. Like in a project, let me give you a project called an example. So automatically I am created a web page, I am created a project called suppose an example, nothing but face detection, nothing but face. Automatically what exactly means my face is automatically visible to you people, right? My face is some sort of expression, it's nothing but already it is a constant values, having a set of values, that my eyes is having some sort of value, and my upper part is having some sort of value, and the lower part already the expression having some sort of value called vx or something. And then I will change some sort of expression, and that expression I recorded into the another value, and another data hit, and another expression into the another CV image, and another expression into the another CV image. So automatically I'll connect the 4 or 5 images already like pre-defined, like with a one proper set. Like one image is for happy, one image is for sad, and one image is for uh, full happiness, and one image for with a stubbled email, like nothing to do. So these are the like we take some sort of images like 1 2 3 4 5 6 images. When we take these images into these images data sheet, and we convert these images, and we take the data sheet and give to the controller, and the controller already we predefined that controller that we already given a data sheet. So the instruction is nothing but sleep, happy, sang, angry, sad. So the instruction set will get you the instructions, and the instruction set will make clear regarding about that the image is equal to the SAD dataset or not. When the image is equal to the SAD dataset, automatically when we sit in a front cam, when we in SAD mode, automatically it will clearly show that the person is in SAD, in which the controller, in which we can create it with a controller, so that yeah, we need to have them unit to store, because automatically when we created a small part of device, when we created a prototype device, we does not need any uh, we does not need any devices as we have prototype, because when we need extra when we need some sort of expressions, when we take heavy sort of expressions, like when we take our 30 to 40 images, or when we take multiple set of data, we need some sort of device. When we need to having store of GB of information, we need to store the data that will send the information to the controller, and the controller automatically, when we connected the output input devices, when we connect it, like when we take a Raspberry Pi 4B with a 4 GB RAM or 32 GB RAM, or whether in a 32 GB RAM we have a lot of storage, so that we can have some set of instructions what we need to given, and we can store the same data into the instructions, and the data can perform all the instructions like that. The machine learning is a main concept in which what exactly machine learning is a main concept in which the data can predefine the instructions, in which automatically the ML, the machine learning and artificial intelligence, the machine is very very important in the human era. So I am just human era is nothing but when we understand the concept and we want to train the machines. Automatically in the embedded systems, we want to train the machine. Every individual instructions is the user want to give. If I want to connect it with the IoT also, I use it to give the instructions, because I need to write the command. Because if in a short instruction, well, if I'm saying that I want to move the robot, if I want to move the robot from one place to another, I am giving the command called friend. If I'm giving the command called back, I'm giving the command called left, right, whatever it may be. So it is nothing but every time the instruction is either maybe in embedded systems or granted with IoT also, I need to give the instructions, because when I want to move the object from one place to another, I need to give the instructions. So that if I'm giving the friend, the automatically the value in which the if I what I mean to say is, if I want to create it with IoT, I am created with the API, application interface. In application interface, in the right key, I am giving the command called friend. So automatically, what exactly the robot could do? The ESP32 sends the information from serial communication to the controller, in which the controller will get the command called F. Already I'm written in the code called void friend, in which I'm written a considerable code called moving towards friend. So automatically what actually the robot do, in which I'm given operation called friend, right? So in which the operation void friend, in which what I'm written, the automatically the controller do. So what exactly with IoT also, I'm giving the same operation, because the user need to give the operations. What exactly in AI means? AI is nothing but artificial intelligence and machine learning, in which we already given some sort of values, or we need to give the instructions of data, in which we give the full data, so the user can understand, like without the user also, the machine can know, like predictive analysis also, like predictive analysis in the sense is the data is maybe the correct or also wrong also. When we given the command, when we take a object, like nothing but classification. Suppose if I want to given regarding about myself as an image, if I want to send my image also, it will take the image. If I want to send a database of different images to my image classification, it will not take, because the data may not be appropriate, because the data must be appropriate with a given set of data, because we need to operate only one set of instructions, or we need to do a specific task, or we need to do a perform a operation set. The operation set must consisting of a data that related to the system. So that related to the system only can give the certain information. So like that, we need to know regarding about the AI and machine learning, that will be the create a huge impact of the people. Like you people can understand like what exactly the pre-process designed, and nothing but the controller actual operation need to send the data. So the controllers what actually do, when we created nothing but when you want to create a controller, or when you want to create a chip on the PCB design, what we actually do, we first take the a normal sheet of the paper, a normal PCB clapboards. We design the components such a way we using the ARDS or ARS software. We created a pattern. We firstly check what we need to check when every individual system or every individual controller or anything. We first check with the inputs or output and nothing but what we need to, how much power we need to require, and how we need to work, because what are the components we need to place on the chip, right? So like that, we need to understand regarding about what actually between the real-time analysis. In the real-time analysis, you can understand that in the A and embedded also, like when we compare to the embedded, you will find like differences. Like in the embedded already is a predefined task, because we already given an instruction set. The instruction set will follow from one end to another. The instruction set in which what we written in the loop, nothing but when we write the code, we having a void loop. The loop is nothing but a recursion. Loop is nothing but recursion. Like it is a cycle process. Already it can done operation. What exactly difference from the AI with embedded system is artificial intelligence already having a predefined, already having a set of instructions, because it is comparatively simple. In every embedded system, the user need to give the instructions. In the artificial intelligence also, we need to give the instructions, but we already given the data, so that the machine can understand. The machine is pre-programmable. It's nothing but the machine is programmed in such a way that they can understand the program in which we already given some set of instructions. The machine understand from the one instruction, then execute and can evaluate the process. Nothing but they can evaluate the process in such a way that is very, very similar to the process. So automatically, when we take a normal individual commands, nothing but when we take a single command, suppose if we take a radar system also, when we take a radar system, or when we take a flight controllers also, in the flight controls you already see, because the flight control in which the radar already having a radar signal, the flight automatically fly towards the in a extent, because when they need to reland, or they need to segregate, in which they having a radar signal, in which you understand that the controllers are nothing but the system configuration is very, very important, because the system already having a predefined set in which they're having a high values. In all systems, like with a embedded created systems or normal systems, or we have a multiple set of sections, every individual system having a set of instructions. The set of instructions where the system need to perform the particular task, or particular task in a such a way in that is embedded systems. In the AI, that is difference. In the AI, already we given a some set of instructions. Already we given a CSV data. When we give the data, suppose if we take a soil, suppose let me give you an example called soil. Suppose if we take a soil called soil wet, soil dry, soil wet. Soil wet condition is 90%, 90%, 94%, 93%, 90%, 90% as a XYZ. So what actually do normally when we take a soil sensor with embedded system, the soil sensor, when we put the soil sensor, the automatically the embedded systems is shown is nothing but soil is dry. That's it. What actually is AI do? We already given a data in which we given a predictive analysis called, if we having a soil state from 90 to 95, it is nothing but a good state. When we having a soil state of 80 to 85, it is nothing but a worst state. When we having a soil sensor is 70 to 75, is nothing but a bad state. So what actually is difference is, when we created AI, we given Excel of data sheet. Excel of data sheet in which the machine learning and the deep learning analysis is nothing but a machine learning and deep learning algorithms, different types of algorithm what we're going to be used. The algorithms will get the data, and the data is predictive analysis is compared to the real-time component. Is it the whether we are created a component, when we created a real-time analysis, the two comparison, because it will get a data called saturation soil sensor is 90%, and it will automatically same data is already the same data we created in the data sheet, in which data is 90 to 90, 91, 92, 93, 90, same data. So automatically what actually do, when it is creating the value automatically goes into the data sheet, and the data sheets will calculate the value, and the automatically will get the accurate outputs. Nothing but the prediction analysis is very 100% true. So what I mean to say is, when we created the artificial intelligence with machine learning, the predictive analysis ratio is very, very, very accurate. Sometimes what actually do is, we may not get the accurate percentage of predictive analysis because of the data what we are going to be used. Because when we take the data with 100% accuracy, so we'll get the actual ratio of the results. When we take the less amount of data, the data will not get the actual ratios, because sometimes you have two set of data. whether when you take the data sheet, whether we download the data sheet or else whether we give the real data. So real data is nothing but the functionality data. What we actually do is when we take the several operations from our end, we use to get the instruction set from user 1, user 2, user 3, user 4. That is nothing but real-time data. What actually the predefined data is, whether we get the data sheet from the Google or like well we get the data sheet from GitHub, whatever it may be, we will get that data sheet downloaded data. So when we send the downloaded data, that will be in the different ratio. When we get the real-time data, that will be in the different ratio. So in the embedded systems with AI is a creative, means it automatically, it's a very unique concept. In the sense when we take the several operations, we may understand regarding about how important it is when compared to the real-time ratio. And regarding about the recommendation systems is nothing but example Netflix, Amazon. So automatically when compared to the automation vehicles, you already I informed regarding about the automation vehicles. Suppose already in the previous slide I told regarding about the Tesla is nothing but automation test drive car. The automation test drive car, what exactly the algorithm is, regarding about the CAN protocol. Also here in the CAN protocol itself states that the when we are connected with the interior part of the car, whether interior part of the car, the external part of the car is connected with the CAN protocol. Automatically, when we do any operation, automatically that can sense the data, and that the data will give the operation set, and the operation set will work on the outer side of the car. So automatically, when we give the Tesla also, Tesla is nothing but an automated Tesla car. It is already having a ratio in which the car move towards the axis. When the car is moved towards the axis, already the car is setting in a certain position. From that position, this car move towards the axis, like already the car having a x, y, z coordinates also, in which the car having a predefined coordinates. In that predefined coordinates only, the car is moving towards the position. So like that is already been defined, because already informed that when we take different set of concepts, like when we take a real-time scenario of the concepts, that is different. Like when we take a normal integration concepts also. So automatically when we take a normal linear concept, nothing but when we take a two concept, like when we take a home automation, when we take a agriculture feedback, when we take a Tesla automation. So say in every concept, like the true embedded system application is nothing but the embedded system can do the task that is already do it task, and what the operation given by the user or user set. Already informed you regarding about the manufacturing, nothing but when we having a design goals, when we created a pattern of design already. Suppose if I want to create a chip, or if I want to create a principle working on it, if I want to do the principle, I need to having a certain instruction set to design it, right? So the my key concept is how I design the chip, or else the controller, or else the main base of the component. That means the base of the component. I need to know regarding about the pin allocation, regarding about the pin fabrication, the thing about how I need to be fabricated, how I need to be verified regarding about the input output pins, and how I need to fabricate all in a single chip, so that I can understand, so that we can understand in a better way that the chip can do the perform different operations, whatever it may be, the with a single operations, with a multi operations, or whatever it may be. So automatically an embedded system can create. So automatically in everywhere you will see the embedded systems applications. So embedded systems is like a unique concept. What I mean to say is with the integration with AI will give you an excellence. With the integration with AI will give you an excellence regarding about how we going to be understand how the missions can understand the pre-programmed, nothing but missions does not having a predicted analysis. When nothing but when we having a set of conditions, nothing but when we having a set of conditions, when we on it, the set of condition will be work, and after the set of conditions, automatically the mission gets to a saturated position or else slow. When we got power it, that's it. When we having a machine learning concept in it, or else when we integrate with the AI. So automatically when we integrate with the AI, it is having a predictive analysis, because it will predict in such a way that it can give you like a interface, like nothing but interface of actually connected with or not. So actually we connected with the machine learning concepts. The machine learning concepts will explain nothing but the data. What I mean to say is the data improvement. So the AI can understand and learn the data. So already when we given the data, so that data can predict and can get the actual ratios. So automatically when we feel like the different scenario of concepts, like when we going to get the real time scenarios, or else when we going to get some sort of elevations of different applications of tubes. So in the real time analysis of like healthcare diagnosis, also in the healthcare diagnosis, the small a lot of devices. When recently when we seen some operation has been done in the extent, like the person has been sitting in some other place, has done the operation with some has done the operation with a unique concept, like he uses some sort of AI and machine learning experience, in which the same robot can do with his hands. Because automatically what I am basically saying that when I'm given a command with the operation set, in which I'm just moving this hand, automatically when give the algorithm to the same as a finger, I'm showing that please as a finger, I'm showing that this is a 5 fingers. As I'm giving the command with the same instruction can be done, because I'm already written a command that the user can take the instruction from a set. Already he's having that the two set of instructions, whether maybe the set of instructions from the one or set of instructions from the two. So the two users can get the same instructions, whether the user data, whatever it may be, the data what we are giving, the data can get the accurate values or accurate values. So it is nothing but the predictive analysis. Predictive analysis is nothing but when we get the accurate solutions. In the machine learning concept, when we see the data in such a way that the data can send the operation. The data can send the operation is nothing but when we having a predictive data is nothing but when we having a data of soil, when we having a data of soil energy, when we data of energy, when we data of consumption unit, like comparison when we having nothing but home automations. Also when we created home automations with AI, automatically the AI will understand that person was there in the home or not. Automatically the AI respond to it, and automatically it get turns off. So normally what actually do with the normal embedded systems or with the IoT? So in the IoT, what we is nothing but we go to the phone and we go to the check into the app, or we go to the check into the server, is nothing but whether the fans in the off or not. If not off, when we was in the other state, or when we was in the other operation, we need to operate it by using the phone, or we need to check whether it is connected with a uh, whether we much connected with a different set of concepts, like nothing but when we integrate when we integrate with this concept, we may get some sort of difficulties, some sort of like we may not get some sort of values, some sort of some sort in which when we given the commands or predefined commands also, that may not work. So that's why I'm saying that in machine learning and artificial intelligence is the real time concepts in which the present data been running on. So on that databases we can work we can work regarding about it. We can work on the future trends in which the industrial industries may work, because the industry is also getting automated every day, because every industry is getting automated. Automated is nothing but every industry wants the automation. Every industry is updating their components, because every day is a present trending technologies, because they want to upgrade their shells, they want to upgrade they want to upgrade their different ratios, because what we actually seen, because we also using the devices that been upgraded, because every day there is a if there is a small issue occurred, also they need to re-verify, they need to create a new devices that will with a different application set, right? That we need to also, the normally embedded systems is a concept in which we have created a unique pattern. Already we having a pattern in which we having a software and hardware combination, in which we need to create the hardware. For that hardware we need to create the software, in which we use a different controllers, or different controls, in which we need to having a different programming set of languages what we actually do. So like that we do the process actually. But in the real time scenario also, may we get regarding about the data exploitation, data analysis also, that may be work on, right? So like that we may occur regarding about it. And right. So So that's regarding about the AI with machine learning. And thank you for the attention. I hope this introduction session provide you some solid fundamentals for your next discussion. I'm excited to dive deeper into the topic in our next session, where we explore the future trends in the embedded systems with AI 5.0. I look forward to see you all, and thank you. Thank you for the opportunity, sir.
Sir, a few participants have posted a few doubts in chat box, sir.
Yeah, okay, sir.
Sir, just a minute. Sir, can you please tell me about how AI techniques implementing in using embedded systems? The
Yes,
question
sir.
is, yeah.
Sir, automatically when we created when we want to create it with when we want to integrate with the embedded systems, we need to know regarding about the CSV files. And automatically when we having a AI artificial intelligence having a data set, sir. So when we create the data set, we having a CSV file. So we already created a data set in which we take the different files automatically. When we take a normally when we take a predictive analysis of a soil, we will take a ratio of soil of different regions, like soil wet, soil dry, soil wet, soil dry. We will take a CSV file in which we already predefined a data. And predefined in the sense we already taken the data sheet. That data sheet can be integrated with a controller. Already we will just send the CSV file to the controller. The controller want to read the CSV file, and the controller will get the data, what the operation is done. And when it is relevant to the operation, to the actual operation, it will give the same scenario, sir. Means equal to it. So we will just
Can you
send the
brief?
CSV file, different set of CSV files, or different set of files by using the techniques. Nothing but when we just reload it, or else when we just save the file, and when we using the Python 3.3, in which we use the Visual Studios, and where we having a two set of operations, and in which we need to write the Python code, and we need to write the embedded code also. In which embedded code automatically by using the Arduino IDE only, Arduino IDE, and in which the Python code having the CSV file, that CSV file is copy and just paste in the Arduino, sir. In which the comport, what I mean to say is the comport, what I'm sending the information to the controller and to the board is the same comport. So that's why the integration can be done.
Sir, one more question is, can you brief about camera interfacing in the embedded system?
Yeah, camera interface is nothing but when we take the normal camera, we having some sort of pins, sir. So automatically when we having a webcam or normal cam, we having a set of pins, instructions, settings. Automatically we know the CV files, sir. CV files automatically when we take the camera having a CV file, sir, in which CV 0x03 or 0x03 having a set of files. That files we have copied and just paste it in the Excel file, sir. So the Excel file, whatever the Excel file we are sending to the processor, nothing but a controller, the controller automatically shows the value. So if the value is equal, automatically the camera is integrated with our controller, sir. Automatically, it will take the image and send it to it.
So one more question, how IoT can meet real-time applications with respect to AI? Kindly give examples, sir. How
So
IoT can meet real-time applications with respect to AI? Kindly give
yes, sir.
examples, sir. One question.
Yeah, when we integrate IoT with automatically IoT is nothing but Internet of Things, what we just automated with our human efforts, sir. So when we integrate IoT with AI, automatically we need already the task is predefined. Already the task can do, the machine can understand the task, because AI having artificial intelligence can understand the task. So the person user can given a command that may be the accurate, because it is having a two dimensions, sir. Automatically when we take the AI, it will maybe yes or no, sir. Two conditions: whether the given data is yes or no, or yes, or the given data is no. So that when we take the IoT support, IoT with the AI, so IoT automatically get the information data sheet, so that we can understand the predefined information, already existing information, what we actually given, or what actually the controller is going to be work on, sir.
Then one more is, I don't know that some participant had not given the question clearly, but if the data in static mode or dynamic mode, then how the process will work?
So normally static and dynamic mode, the data automatically reloads it, sir. When we reload the data into the chip automatically, when we take the Raspberry Pi 4B automatically, when we have a static or dynamic RAM cell, automatically the unit of information what we actually send that can receive the that can actually the work on, sir, because the two operations, whether in static some sort of issues may be occur because we use some sort of algorithms with the CSV files automatically, some sort of files, because we are just control the COM to the controller automatically. When we connected the laptop with a controller, it is connected with COM port with called COM port 7, COM port 6, COM port 5, COM port 4 automatically. Some COM ports may be work on with a static, some COM ports may not work because some sort of like inputs or some sort of outputs does not need having a heavy information, right? Does not need a full information. They having a one set of data that will execute. Some sort will having a predefined that will have need to have around 100 to 110 instructions. So that's why some need having a static can be work on, sir. In which
So one more question, last question. How do you integrate AI algorithms into resource constraint embedded systems?
sir, in which
How do you
we
integrate that?
use when we take AI algorithms, sir, normally we take artificial intelligence with deep learning. In which deep learning we take the algorithms like we take the algorithms in a different, like we need to reload the algorithms in Python 3.3u. When we upload the files, we take the CSV object files, sir. In which the object files we already having algorithm set like nothing but when we taking a face as a one like different constants, like that when we take a different constants, about to the one constant will get a value, sir. On that values only we will work on, sir.
వాళ్ళ డాడీ సైడ్ వస్తే నాకు సంబంధం లేదు మేడం అని చెప్పిన నువ్వు పడుకో ఫస్ట్ పడుకుంటా జస్ట్ నాకు ఏడిస్తే నచ్చదు జస్ట్ నాకు నిజంగా నచ్చదు నువ్వు ఎంతసేపు ముద్దుగా మాట్లాడి ఎంతసేపు మాట్లాడినాను నాకు ఏడిస్తే నచ్చదు నేను మాట్లాడను
Sir, just a minute, sir. Sir.
సరే మంచిది
Okay, sir. Dear participants, still do you have any doubts regarding this session? Okay, sir. Thank you. We would like to express our sincere gratitude to Mr. S. Hemant Kumar for delivering such an insightful and informative session on Introduction to Embedded Systems. Your expertise and thorough explanation of embedded systems, along with real-world examples, have provided our participants with a strong foundational understanding of the subject. Your valuable contributions have truly enhanced the learning experience for everyone. Thank you once again for your time and knowledge, sir. Thank you, sir.
Thank you, sir.
Dear participants, we have posted a link for session 2 feedback. Kindly fill feedback forms. Thank you.